you can have kind of 5-minute presentation with 3 minutes of Q&A. Thank you very much. So without delay, I would like, first of all, to invite Dr. Maimesiang to present about a topic called estimating the optimal evacuation route for emergency event. Dr. Maimesiang, please.
Okay, hello everyone. Good afternoon. I'm Maimesiang from University of Computer Studies, Yangon, Myanmar. Today, I would like to present the developed system of estimating the optimal evacuation route for emergency event. Move by myself. Also, this is a part of the project title, Context-Aware Disaster Mitigation using Mobile Edge Computing and Wireless Mesh Network. And in this project, this is, you see, SY is deploying the part of the optimal route finding system is developed. So this is a emergency for, we consider our system is for the emergency event. Emergency event can happen any time and everywhere without message or alert. The emergency and emergency situation can be caused by the disaster, such as the wildfire, natural disaster, cyclone, and tsunami, strong wind, earthquake. It can be caused by explosion, etc. But in our developing country, Myanmar, there has some fire disaster is more greater than the other disaster effect. In Myanmar, about 70% of disaster are fire. According to the data of the Department of Central Fire Department in 2021, there are 2,107 fire outbreaks are occurred. 151 injured persons and 105 are dead. And country is lost there 33 million deaths. And people are lost their home is 4,154. For this year, it's only the data for January to October. So it's 2022, January to October, the fire outbreak is there, 1,797 cases, 142 injured and 79 dead. Loss of their property is 320,643 million deaths. 6,352 people are lost their home. According to this outbreak of 1,797, there are some source of kitchen fire is 172, and 360 by negligent fire, and 390 cases by the electronic circuits problem, and 712 by arson. 131 is case by fire, forest fire, and other except fire is there 26. In this, according to in this data, in city of Yangon, Myanmar, is 181 outbreak of the fire is lost there 947 million. Because it's metropolitan area in Myanmar have their complex road network structure. The complex road network structure can cause delay the driver and can increase the damage level. Example, crossroad, narrow road, and block road. This figure shows there some problem of the road network. In Myanmar, many places has their one end road. It is a one side is also closed, and narrow road. Narrow road is cannot enter the vehicle. There is a very narrow, very small wide to enter the vehicle. Something is broken by close. So this is the road close. Now we consider only the bad condition of the road is one end road, narrow road, and closed road. According to this situation and this condition, we consider to develop an optimal finding system for emergency vehicle. It is such as a fire vehicle, police vehicle, and ambulance. And at that time, I would like to express what is the optimal route. Optimal route is there between two locations. This is an incident location and destination. It's a service center or some recuse center and hospital or something like that. These two locations can be go safe and convenient road along there this way from one place to another. Then we develop a system of optimal route finding system. This figure shows the overview of the proposed system. Firstly, we collect the information of the incident place. Incident place is contained there as a location information, and then we identify that this location by using the Google Map and some map. After then, we find the close emergency service near the incident location. After computing the close emergency service location, and we find the optimal route calculation will be started. For this research is we consider for the comparison of the original method and proposed method. This system is based on the web application. Let me explain about how to generate the road network database of Yangon. For this testing, we consider the Yangon road network because this Yangon road network is consist of a lot of the closed road, narrow road, and some of the one-end road. The data sources from the Myanmar Fire Bridge, Myanmar Fire Department, and a land organization, Google Map. And then we using the GPS device of the government extra 10 device. We collect the data of road and some of the hospital, clinic. This one is the 85 hospital and clinic, 41 fire station, and narrow street, location of the closed road. And we collect the latitude, longitude of this location data. And then we doing some identification of this collection data of network of Yangon region. We fix some junction point and something of node place is, we collect the number of node place is there, 554,048 number of node. And then we consider for the edge between the link of this node is not including the closed road. One side road is number of edge is drawing there 131,209 edge. So this creating a better map of Yangon road network data analyzing and adding the spatial data information are performed by GIS. Open source package of GIS, post-GIS map and GIS server are applying for this data collection. Let me introduce about our digital algorithm. Initially, digital algorithm is there, how to say this is a blind search algorithm, only consider from one node to other, remaining node, they find that they are measurement and distance. But our modified digital algorithm is considered the first initial node and they are neighbor node. And then we computing of the nearest neighbor and find the measurement. For this algorithm is firstly, we consider the source node is firstly, distance of source node is the 0. And other of the source nodes from other node distance is also set in infinity. We consider the set of all nodes in graph until this is true is not empty. We find the distance of from source node to other nearest node. And there has some distance is smaller than the current distance. We put this node is replaced to the source node. Then finally, repeatedly this algorithm, and finally we get the sum of the shortest path. Let me explain about the impact of the proposed system. We can how to use this proposed system. This system will help the user and business to recover the safeness and convenient way and direction between to any point. This is a location or some service on the road network of Google Maps. It is also deployed to such nearby refugee area and carry the best route to evacuate people from the dangerous area. It will provide to develop the partial sequence route algorithm for the trip planning mobile application in ASEAN heritage region. This system also helps to reduce the delay caused by weak infrastructure road network for emergency vehicle. Furthermore, the proposed approach of optimal route finding system can be applied to various kinds of application in social network. This shows there some experimental result. Firstly, first figure is show there some information getting and put the some incident place, and then find the nearest location of the emergency service. So the second figure is show the nearest emergency service. And then result of optimal route map. After finding the 3 closest and 3 nearest emergency service and finding this or choose of the 1 emergency service and how to go the incident location. So using our proposed the modified disaster algorithm. This figure showed that there is some route of the from incident location to destination. Let me conclude my presentation. The optimal evacuation route estimation algorithm is developed for complicated and structured network of Yangon based on modified disaster algorithm. It will be reduce the risk of emergency situation and save the people's life. The optimal evacuation route of vehicle is predicted. The closest emergency service location are examined for incident place by using geographic data and display the route result with detailed direction. The proposed route will have emergency recruiting directly to reach the incident location in short time, save their life and property. The proposed algorithm will reduce the memory consumption and the processing time. On integrating the real-time road traffic condition obtained by IoT sensor will be considered improve this proposed approach. Okay, thank you very much for your attention.
Thank you very much, Dr. Maimei-san. So may I ask if any question from the floor, please?
Yes, yes.
One question.
Thank you for your presentation, Professor. I would imagine that, can you go to the last slide?
Yes.
The one. Yeah, I would imagine that the last point is very important. Because the dynamicity of the real world environment, it plays a lot of crucial role in order to get the correct accuracy, right?
Yes.
So it's pretty important. But why don't we take that as part of the proposal? Why? Because it seems like when you say that it almost like you don't want to do it, or on getting the real time. We consider. But I would say that it's very important part. Don't you think so?
Yes.
Do you plan?
This is really how to say this is the optimal route estimation and optimal route finding algorithm will be used at the some trip planning and something like that. It is a bar routing how to find that this is a good way and from current location to destination, how to using which loop is we will use. So this is a finding for the bus route, and some is the visiting loop, and this is based on the graph theory. So we can use another optimization problem. We can use this as the same things. Yeah.
Okay, thank you.
Any more question? One more question, please, if any. Okay, so thank you very much, Dr. Meme-san. So next, I would like to invite Mr. Thai Heng from Cambodia Academy of Digital Technology, Cambodia, to present about the indoor human detection and identification using commodity Wi-Fi. Mr. Thai Heng, please.
Thank you very much, Dr. Sarah, for the floor. First of all, good afternoon, and thank you to ASEAN IVO committee for giving me a chance to present about my proposed project idea for this forum. So today I would like to present about our proposed project on indoor human localization and identification using commodity Wi-Fi. So let me introduce some background on why is it possible and what is the background behind the idea of having this project. So radio frequency is something we take for granted as it cannot be seen, obviously. But then after however, we cannot see, it's transmitted, it's being around us from day to day and every day. And it's get transmitted, reflected, scatter around the object in the area, in the environment and all of that. And that is something we can get with the information at the receiver. So this is something that can lead to the possibility, what if we can get those signals, and then what if we can get some information about the environment regardless of how the radio frequency is being propagated in the environment. And another thing is that why are we considering of using commodity Wi-Fi? Because recently there's a lot of, we can see a lot of Wi-Fi router. I mean, the home one, the gateway used one, has been used in many in almost every household in the urban. So this is something we can consider. What if we can use those signals from the Wi-Fi we are having at our household to actually implement this project on using this ready installed infrastructure to do this. Another benefit to using this, regardless beside sensor-based such as video camera and all of that, is that Wi-Fi is a passive method which can be used in both in line of sight and non-line of sight, meaning you can go beyond the room and you can still detect it. However, in my presentation, it will be only focused on the indoor environment. And another thing is that using this technology, the user is not required to be mounted to any device. However, I like to mention that it is not the competition with the mounted device on sensing to our smart device. It will be a complement to those systems. So the purpose of this project is to build an accurate, non-invasive sensing application for localization and identification problem. So localization probably regarding how a human interact in an environment, and identification regarding the activity, also the authentication purpose. So let me just quickly, we will not go into detail on this enabling technology, but OFDM is one of the main technology that lead to the purpose of having this this project. And MIMO, another very important technology that lead to this as well. We got having the multiple input, multiple output with having multiple antenna on those wireless communication device. And another thing is CSI, which is obtained by the OFDM technology. CSI is the information that we get once the radio frequency, when the signal is being transmitted from the transmitter, and at the receiver side, you can get those CSI information. It's the channel state information of those small frequency in the wireless communication. And I just another one is to point out is that CSI is being used in multiple way. In one of which is if we use it in a time series way, it mostly used for identification purpose on how we walk, how we fall onto the floor, and all of that. Those kind of information, when the signal is propagated and received at the end device, it's tell a different story. So this is the general method, because in this project we will be using both of the method to produce both localization and identification problem. So first of all, there will be unit and input. Input normally it will mostly be the channel state information, but one of the problem in the input is that the device have to be in the same network, I mean the wireless communication network, to receive those data, because channel state information cannot be received by the outsider. So that is one of the problems, is because if we are talking about unaided or maybe non-cooperating device that is not in the network, it's not possible to receive this information. So there is another problem in that part, where how can we use another receiver or the outsider device where it can actually send the signal being propagated into it, and then calculate the channel state information with whether it is not in the network. And then moving to the signal processing part, there'll be three main methods, which is noise reduction, signal transform, and signal extraction. These three methods is used very intensively, although it really based on the application that is being applied. For example, in the localization problem, we will have a very intense noise reduction, because this kind of information is very sensitive to noise, in order to retract those information. But for identification problem, noise doesn't matter much, because it mostly an add-on or just a reduction a little bit on the amplitude and the phase of the radio frequency. But that's also add the uniqueness to the propagated signals that we can identify using machine learning method. And going to algorithm, there will be three main currently in the current state of art solution in this area of application. There's a modeling based, learning based, and hybrid. Modeling based is refer to the part where we do actually calculate the location based on some information such as angle of arrival, time of flight of the propagated signal, and all that. And learning based is mostly involved using deep learning to do identification problem. So mostly when it comes to identification problem, mostly used in machine learning based algorithm, and sometimes hybrid, because some identification problem are sensitive to noise, but it's not very as sensitive as a localization problem, and which will lead to the application level where we have the localization of the people. It can be a 2-dimension XY in a plane, and also in a 3D dimension. And let's come to the input data. So for this one, I will introduce a little bit on the tool where we can use to extract those information for the cooperating device, meaning the device which are in the network itself. So those tool CSI tool and Azero tool, Azero CSI tool, which developed by one of the university in Singapore. Both tool can be operated at 2.4 gigahertz and 5 gigahertz. So this is the most used software that we can use to put in the receiver to extract the CSI information. But for, like I mentioned earlier, that for non-cooperating device, it will not be possible to using these two tools. So this is something we are looking into as well. Moving to signal processing in this part, I would like to mention regarding how we can use those information in time domain signals and in frequency domain signals. So in time domain signals, like I said, mostly we use for identification, because in time domain, we usually use machine learning such as time warping or Euclidean method to really identify, to compare how the signal being propagated. So it's require annotation as well on this identification problem. So one of the heavy weight in this work is to annotate and knowing that when we set up the experiment and the people is in the room, and then we have to wait 2-3 seconds to annotate that, okay, there is a people during this time, and then the CSI will be able to tell that during this time what is the uniqueness of the propagated signals to really identify that there is people in this room, in the room. And for the frequency domain, mostly I used for human localization and tracking, where we calculate the actual positioning, time of flight, how far it is. And one of the methods is also using received signal strength, where we can identify the strength of the signal from the transmitter to the receiver to really know the furtherness of the object. Let's move on to different algorithm where we can use for both the localization and tracking and identification. So for localization application, mostly are modeling based, and the two main methods that we usually see are angle of arrival, where this also based on the router as well, because some reception you don't get the angle of arrival because you only have one antenna, but you also get, but it's not very accurate. So the resolution is quite big in terms of that. So mostly there also a method where they propose a multiple antenna reception so that we can calculate a more precise angle of arrivals and also time of flight. Another for algorithm on identification, mostly using machine learning and most binary and multi-class identification. For example, for one of the model on knowing that the human is falling on the floor. So for this kind of application, we can just use a binary classification to identify the unique signals of a person being fall or standing. I will move quickly a little bit. So here are some of the promising application: localization authentication system, vital sign monitoring. This is regarding the healthcare system. Also gesture recognition, one of the examples you see in the pictures, where you can just do some sign, and then the uniqueness of the propagated signals can tell whether it is what is the hand signal you are doing. And there's also human activity recognition, whether you are running, you are falling, or you are walking in the room in a way. So here are some challenges and open opportunity in this area. Right now, they coexist the robustness and resolution, because the resolution right now is quite big. The open opportunity for this kind of research also in the field of multiple scenario, multi-data source, which is also part of IoT source, where we can have it joining the IoT system. And while sensing for other species, maybe we can detect there's animal in the area and somehow. And yeah, so this is the end of my presentation. Thank you very much.
Thank you very much. Okay, so may I ask any question from the floor?
Thank you very much for your interesting presentations. Recently, there is a new method for indoor human localization and identifications using Li-Fi, light fidelity. What's your opinion about this? Rather than compare using Wi-Fi compared to Li-Fi, do you have any opinion about that?
Wi-Fi is sensitive to light, but Wi-Fi is not sensitive to light. So whether it is dark, mostly it's Wi-Fi, not Wi-Fi. I mean, radio frequency in general is more robust when it comes to environment attenuation. That's why, and one of the reasons we are using Wi-Fi is because of the infrastructure that we already have with this kind of this kind of device. So yeah, that is why we are considering of using Wi-Fi. However, I have to say that although Wi-Fi is something we consider, it's very difficult because there are many now. There's Wi-Fi 7 right now, so we also have problem with the interoperability with the different version as well. I think. Do we have another?
Thank you very much for the question and the answer. So now we finish the second presentation and we move to the third presentation about the blockchain development to enhance the performance of logistics service provider networks. So may I invite Mr. Dr. Sarun Sumriddetchkajorn to come on the slide.
Good afternoon. My name is Sarun Sumriddetchkajorn from Brunei University, Thailand. I would like to present the project related to the application of blockchain technology entitled Blockchain Development to Enhance the Performance of Logistics Service Provider Network. Logistics services account for the majority of ASEAN trades, such as cross-border sales. From 2020 to 2021, ASEAN cross-border sales increased 11 times, particularly recruiting the ASEAN economy from the COVID-19 pandemic. The logistics industry is made up of several parties who work together to form a complex logistics service supply chain that is plagued by the main issue of information loss. Due to the large number of supply chain participants, many researchers believe that blockchain can accelerate the issue of information loss from the beginning to the end of the chain. Moreover, since the implementation of blockchain technology in the international logistics company have reduced logistics expense by approximately 25%, resulting in outstanding performance in transaction cost reduction. However, the blockchain technology is still prohibitively expensive for small businesses. In this project, we will look at blockchain as a building block to create a prototype blockchain for logistics service supply chain, with the goal of improving the efficiency, trackability, and real-time sharing in logistics service industry, pertaining to the local small and medium logistics service supply chain to drive the ASEAN economy. This study contributes toward enhancing small and medium logistics service provider, or LSP, knowledge on blockchain technology, and kickstart the blockchain adoption in order to reap the benefits of disruptive technology in their logistics business operation. For the logistics business operation, begin customer service of the LSP receive a record detail from the customer or the cargo owner. The detail of information is distributed to the transportation unit of the LP. The transportation unit considers the availability or suitability of the company's truck, plan delivery to the and provide detailed job information to the site truck driver. On the other hand, they order the transport work to subcontractors transportation provider. Information about the job is forwarded to the subcontractor truck driver. Truck driver of each firm will receive the information related to the loading and delivery of cargo to bring cargo from the loading point to the destination according to the customer requirements. For the purpose of scientific and technological blockchain method, first consider for the following blockchain feature. Blockchain transaction takes place via a peer-to-peer network or a decentralized manner. The peers represent the network participants with a key blockchain component that their peers hold the smart contract and ledgers. The smart contract or chain code is the code that has access to and may answer ledger and is typically invoked by user application external to the blockchain network. Blockchain can be viewed as a block link, where access of transaction is contained in each block. Every block encode its hash value with its unique ID. Each block is linked to the ones before its parent block, forming a chain that can be tracked back to the initial block. The second, here are the primary technology that we will use to develop the prototype blockchain model, including the Hyperledger, Node.js, and Bootstrap. For the implementation of method related to the business operation of logistics provider, first Peer 00 first ask for the transport to Peer 01 with transportation of the information. Peer 01 creates transportation query and share it to Peer 03 with job assignment information as one choice. Another is Peer 01 submits a work order to Peer 02 with the work order information. Peer 02 then creates a transport query and share it to Peer 03 with job assignment information. Peer 03 starts an assignment with the loading information, creates and completes the assignment with the important delivery information update. All peer, especially Peer 00, can monitor and entry process in real time using online device to update the service status with the customer. Peer 01 and Peer 02 can be tracked and track the truck status and use summary and history information to control and manage the fleet for more efficiency. For the scientific and technical impact of this proposed model, blockchain technology is suitable for collaboration and information sharing platform due to its main feature of decentralization. For resistance and transparency, because blockchain can overcome traditional client server system. Data sharing between parties is a complex process that is susceptible to a variety of cyber attacks. It is required to develop the blockchain model of data sharing and monitoring in the logic domains because most data is confidential client data. It will also be an important foundation for the development of Logic 4.0, which is linked to the principle of automation, integration, and intelligence. Moreover, for the societal and collaborative impact in this project, first, communications between LSP and their partner is a key driver in developing flexibility and collaboration capability in logic service supply chain context. LSP must process their customer to share useful information about operation and logic. And LSP, for example, can be developed an information monitoring platform to facilitate information sharing with its supplier and customer. Local LSP for stations must collaborate with extensive business partners who have knowledge source to provide value-added service to customers in the innovative ecosystem. The outputs of the project for new application of scientific, the proposed prototype model is working model that satisfies the basic functions of tracking and tracing system, which is a key indicator of the performance of LSP. It could improve the performance of the LSP blockchains by integrating the concept of Internet of Things and cloud technology for smart fleet management. The outcome of societal and collaborative technology that be transferred to the company. As an outcome, the developer can be used this study as a framework for blockchain development in the logistics service domain. This may aid in the spread of development. As a result, future development costs will be lower, and the use of blockchain technology in relevant sector, particularly the local logistics industry, will benefit. Global enterprises deem blockchain technology critical. They make it a top strategic priority, whereas firms prefer a supply chain or partnership to increase their annual revenues. Blockchain technology is central to transaction performance and management, which will have a positive influence on future cost and service time. In conclusion, the project has examined the development of blockchain technology for the logistics industry, a user service sector that plays a key role in the development of countries such as ASEAN. The application of blockchain technology is realized through the concept of blockchain customization prototype model for small and business scale logistics service supply chain. The previous blockchain platform of Hyperledger Fabric by integrating the concept of Internet of Things and cloud technology is a consideration model. The use of this blockchain-based technology is critical to improve the flow of information in the logistics business network and provide a higher performance of service cost and time to customer. That concludes my presentation. Thank you much for your listening. Do you have any suggestion or question, please?
Thank you very much. So may I ask you any question from the floor, please? Okay. Speaker.
How to differentiate from what they are doing. Maybe
Yes,
just to repeat, I think IBM, Microsoft,
Yeah.
or even Oracle, they are doing something along this line, blockchain for supply chain.
Yeah.
Yeah.
Further on, I would like to explain the concept of this project that we need to develop this blockchain technology to overcome the business of traditional system. From the best performance of blockchain related to the centralization, and it's make us for the transparency. And also, when we operate with the logistics service supply chain, this operation based on blockchain is related to the several company to make the same information to operate the supply chain. And in case of the sharing data along with the supply chain, is very difficult to manage under the traditional platform. Such as the EDI, and that's maybe has before. One benefit of blockchain that I said can be overcome for this weakness that I explained, and I think for this technology will be important for the industry or enterprise in the future, because right now the big company, large scale company already implement for the blockchain, but there are limitations for the small and medium enterprises that we need to launch the knowledge of blockchain to them and need to kick off this benefit technology to them. Thank you.
Okay. We have 2 minutes. If one more question, if any question, we can take one more question. Okay.
Take into account, if you take into account the government regulation, for example,
Yeah.
in this work, That's number one. And then number two is how do we maintain the standard?
Yeah.
So I think if many regulation, maintain the standard in order to have a very good blockchain technology. Yeah.
Thank you very much. From our project, this is the prototype model that try to launch to the small and medium business. Deeply in the detail of the develop, we first ask to the company about their requirements and their regulation that they do the business right now. And we get the information on requirements from them to develop the prototype model first. The limit form of the prototype model operates only the network of logistics service provider, and maybe in the future this blockchain technology maybe can extend to another concerned party, such as the government. For example, for the custom, when the logistics service provider move the cargo cross border. I think if this blockchain can show the performance when we kick off this prototype, the government that may be related to support the business, maybe more have benefits that to support to develop the blockchain technology for the small business in the future. Thank you.
Thank you very much. So now it's time's up, and thank you all the three presenters. Let me conclude the session. Thank you.
All right, so welcome to session 4. This is ICT for Secure and Smart Communities. And the first presentation we have today is Trustable Global Navigation Satellite System for Secure Community and Applications. And the presenter is Professor Chikiatsio. Please.
Yeah, good afternoon, everyone. Good afternoon, committee and participant. My name is Dr. Seo from University of Glasgow. Today, I'm going to present a topic on trustable global navigation satellite system for secure community and application. So what is GNS? Basically, GNS is the baseline technology to provide precision, timing, and velocity in various aspects of application. One of the very common GNS that in our daily life is the GPS from US, Beidou from China, QZS from Japan, and of course Galileo from European. So what does this GNS do in this nowadays world, especially in terms of smart initiative? So example, in terms of so-called the smart grid, we will have so-called GNS timing is important to make sure the synchronizations of the so-called power signals is always maintained. Secondly, in terms of smart finance, so the GNS timing itself is need to be so-called being used to record down the precise timing of the transaction. And of course, in terms of smart network, the comms network, be it 5G, 6G, nowadays, especially 5G, we need to provide millisecond latency. And of course, this in order to fulfill this capability, the reference signals must be even high resolution in terms of milliseconds or in terms of microsecond, and that is provided by the GNS timing. And lastly, for the so-called smart transportation, especially autonomous vehicles that is going to roll out pretty soon, or rather slowly in every country, they are trying to move, implement. All these rely on precise GNS timing and partitioning. So example, during COVID, we have been so-called stay at home, doing all these Grab delivery. All these so-called services is being enabled because of this GNS timing and partitioning. And what happened if all these so-called GNS timing in terms of timing, position, and velocity has been so-called spoofed? So it has been proved by Tesla that a simple $200 spoofer can manipulate the sets of a fake GNS satellite to change all the information of the position, velocity, and timing. And of course, has that been done in so-called spoof in our ASEAN country? The answer is yes. So for example, in ASEAN country, we suffer some of the GNS spoofing threat. In Malaysia, it has been known that Grab drivers steal bookings from other drivers by doing spoofing. And Grab driver also give their fake locations to the Grab company, such that they do not want to take a job that is not in the preference. At the same time, recently, I think it's 2 months ago, in September 26, 2022, it has been suspected oil tank has been spoofed and caused collisions in the so-called with another so-called tanker along the Strait of Malacca. And of course, the other thing is it has been known that so-called spoofer can masquerade as a potential Grab driver to customer, and somehow it may be cause some dangers to the customer. In Indonesia and Singapore, it has been shown that driver itself spoof their location for these GoJet so-called apps, such that customer at the preferred location can be assigned to them. And the target of this so-called proposal for today's is to so-called provide a real GNS signals to any company and application that make use of GNS, such as transportation company, not limited to, example, Grab. And of course, any GNS user, especially ladies and kids, because it may so-called endanger their so-called the life. And lastly, but not least, is the national infrastructure, such as 5G and 6G, because all the important timing reference arises from all the GNS timing. So I think here is a few picture where by $200 head RF that can be buy from so-called online. At the same time, all the source code has been easily available. It can be shown that this driver example install all this software inside this head RF, and it can so-called spoof their own location or even the nearby vehicles. So we have so-called since 2 years ago, we have so-called provide do a development work with Singapore Land Authority. It has been funded by GovTech, which is under the Singapore Prime Minister Office at the so-called funding about 800K to develop GNSS navigation message authentication over the continuous operating reference system network. So this phase 1 prototype development basically is for Singapore Land Authority. They have around 8 reference stations in Singapore, and is jointly developed by University of Glasgow, Singapore, NTU, and University of Tokyo. So what does this so-called this GNS authentication system work? Basically, the real GPS signal has been so-called received by all the reference stations. For example, by the one at NTU, we use NTU as a reference, for example. And of course, the real signal has been so-called rubber stamp with a digital signature. And this digital signature will eventually send out over the cloud network to over this cellular network to all the IoT devices on the ground. It can be any so-called Grab taxi, autonomous vehicle, or even the cellular handphone. And in the event that there is some spoofer out there, so for example here, there's one spoofer out there, it is sending a spoof GNS signal to masquerade that it is a real GNS signal. However, for example, this autonomous vehicle, it is receiving so-called the real signal, GPS signal, and the spoof signal. But at the same time, it has been receiving the digital signal for the real GPS signals. It will able to so-called correlate. So, example, the spoof signal has not been rubber stamped with digital signature for the so-called by the reference signal. Therefore, it will be so-called validated by the IoT devices. In this case, autonomous vehicles say that it is not a valid GNS signal, and therefore it should be thrown away. And this is some of the experiment campaign setup that we have done together with NTU and University of Tokyo, whereby this core network itself, basically, in short, basically the GNS signal that received by this core network, the messages will be so-called being hashed and create digital signature. This hash key and the digital signature will be put inside the database. So in the event that the client, regardless is any IoT devices, want to validate whether this particular GNS signal is valid, is real, therefore, this so-called the receiver itself will go to the so-called database to fetch the so-called the digital signature for the real signal. And in the event that even there's a spoofer, it will say that because spoofer don't have digital signature, it will be valid that it is either invalid or a spoof signal. So therefore, it will be successfully thrown away, or rather to identify the spoof signal. We have done some experiment using so-called this RF. Okay, basically it's a simple device, $200 will create a spoofer, and then we conduct, of course here the picture only show two, that there's more than that. So basically we have done some experiment in the so-called outdoor environment, and you can see that under here, this is so-called supposed to have 6, but then in the event that there may be some spoofer, you identify that there is only 4 valid. And this is the experiment at the open area that we've done in the NETU so-called open space, where one of the handphone is mainly as a server and the other handphone is mainly as a client. And of course, all this authentication has been done over the cloud. This is using something called channel hashing algorithm as part of the so-called delivery. And inside this so-called, under this so-called project, which is an 18-month project, we have so-called fulfilled the requirement that given by the authority. The KPI so-called given for us is successful rate is about 90%, 95%. But however, for IoT devices, we have reached 99.4% success rate. And for the Android phone is 99%. So as you see here, we conduct some experiment in the so-called on the rooftop of the NTU so-called S2 rooftop, AAA rooftop. And basically, the handphone itself can so-called the client itself can authenticate which satellite is considered the real one or fake one. So for example here, because authentication has not been successfully done for the so-called satellite SVD8, therefore it says that it is totally so-called not successful. So with the success of so-called phase 1, we hope that we can outreach to so-called this technology to Malaysia. Why? Because there is in the East and West Malaysia, there is 79 call stations in the so-called West Malaysia and 21 call stations in the Sabah area. And of course, there is a so-called 6 more for particular purpose like Marine Department, 1 for so-called the Civil so-called Aviation Authority. And there is also 23 R&D core network for us to play around or to so-called implement. And therefore, we would like to suggest to outreach to Malaysia, we can leverage on these 23 so-called R&D core station. And what is the impact if we roll out this so-called DNS authentication for Malaysia? Of course, phase 1 in Singapore. So in Singapore, the success of the so-called DNS authentication scheme, we have so-called Accelerate Very Smart Nation initiative that basically rely heavily on GNSS, especially for SLA. They primarily need to give CM accuracy, GNS accuracy, position accuracy to the customer, especially for the so-called construction. And therefore, this can help them to prevent so-called spoofing on the piling, and of course for drone building facade inspection. And of course for SI and GovTech, they can build secure mobile apps for community. In Malaysia, because if going to implement this, we definitely can so-called remove all the above mentioned GNS threat for business accessibility. Driver will be assured of the guaranteed livelihood. Commuter will be assured of the safety. And finally, national infrastructure can be so-called integrity can be maintained. And especially this is also one of the key objectives of Malaysia Space Agency. And one of the most important things that part of this project is that Malaysia Government Smart Initiative that so-called, especially the Kuching urban transportation system, they are going to implement fully autonomous transport systems. So for example, here, the system itself will be fully autonomous. And in terms of collaboration impact, we are trying to definitely based on phase one that already include NTU, University of Tokyo, and Glasgow, Singapore, we can extend to UTM, UNIMAS, and Sumber University, and of course, the core network partner in Johor and Sarawak. And this is similarly, based on this so-called implementation, we would like to leverage on Johor, the Iskandar Net, and Sarawak, the so-called Sarawak core network. And this so-called, this is similar to what we have done for phase one, except that we need to adapt to local context. And the outcome here is, in terms of outcome, we are trying to develop new customer GNS solutioning for local context, and of course, eventually, can transfer know-how to local company, like example, the KUTS company or GNS cybersecurity startup, and also pave the way for the future nationwide big data analytics. And in terms of outcome, as mentioned, we not limited to, currently we have cooperation with NTU, University of and University of Tokyo, and we currently we have talked to UTM, UNIMAS, and SUTS, and the core network partner in Johor and Sarawak. We definitely, it's not limited to all this, we can welcome more collaboration. And finally, the target, as mentioned, is to prevent malicious spoofing by providing real GNS signal to any company application that make use of this GNS signal, and of course to any user, especially ladies and kids, and finally the national infrastructure such as 5G and 6G. And the method is basically GNS authentication on the navigation message. And finally, as usual, as mentioned just now, we want to make sure this novel centralized GNS zero signature can provide business sustainability, safeguard the livelihood, and protect the safety, personal safety of the ladies and kids for private right. And finally, the national infrastructure reliability and integrity. Thank you.
Okay, thank you. I think we have time for a very quick question, maybe within a minute or so. Anyone? Yep, there's a question there, the lady there.
We saw that you have like a high accuracy on the testing. So I'm wondering, is there anything that you need to compromise to arrive at such results for the testing? Any compromise that you make to receive such very accurate results?
Because this is when we sign the contract with so-called GovTech, there is a few criteria. We need to ensure 95% so-called authentication rate under certain environment. So one is open era, one then is so-called not so open era. So there's some accuracy involved. Okay. So of course this one is currently it's open era, and of course the project is going to be another 3 more months. Okay, to move to more testing. Of course we need to see all this multiple environment will affect or not. Yeah.
Okay. Thank you very much.
Okay. Thank you. Thanks.
All right, so our next topic is investigating the detection of tortured faces in scientific literature. And our speaker is Ms. Putinit Lay.
Okay, good afternoon, ladies and gentlemen. So my name is Putinit Lai, and I'm from Cambodia Academy of Digital Technology. And today I'm delighted to present my project is exploration of the total faces detection. Okay, let's get started. So first, I would like to introduce why we come up with the idea to detect the total faces. So first, I want to present the work of the Carbanak and Labey. They claim in 2021 that the meaningless, randomly generated scientific papers end up being observed and sometimes sold by the various publishers with a prevalence estimated to 4.29 papers every 1 million papers. So it means that even there's existing scientific papers, but some paper is still fake because of the fraudulent researcher. They try to create a fake paper to sell. And as the Kabanak and Labe, they also try to figure out how they generate the fake scientific papers. So here are the two, for example, the mass gen tool and the science gen tool. This website, yes, this tool can generate the mathematic research papers. And one more thing, when they try to deep dive to the root cause of how they try to generate the weird phrase. So for example, the phrase artificial intelligence, it should remain the same in every context. But when they use in the paraphrasing tool, it become the man-made brain powers. And sometimes it's become the counterfeit consciousness. So when we read it, we think it's not the human generated, it's machine generated text. All right, so now I would like to introduce two new terminologies, is the total phrases and the expected phrases. So the total phrases are the unexpected weird phrase instead of the established one. For example, like the phrase that I mentioned earlier, like the counterfeit consciousness or the man-made brain power, we consider it as the total phrases. And its expected phrases should be artificial intelligence. And I would like to introduce some more total phrases, for example, like the unused York. And we see it's in some phrase, in some paper. Actually, it's the New York, but because the paraphrasing tool try to paraphrase the word new, so it become unused York. And one more thing about the algorithm, like it's the understand-based algorithm. Actually, it's the nail-based algorithm. And for another example is the imaginations. Actually, it's the expected phrase is developing countries. All right. So my objective of the study is to detect the new kind of the unlisted total phrases in the sentence automatically, because before we have the human evaluation on what are the total phrases. So we can only detect the total phrases by doing the rule-based with the pre-listed total phrases. So by make use of the machine learning and deep learning tool, we want to detect the total phrases automatically. I mean, refer to the unlisted total phrases. For example, if we try to detect what, to see the phrase, it is yes or no by doing the binary classification, for example, it is, well, for this example, we try to detect the total phrases. So it is commonly acknowledged that FDI is one of the essential wellspring of capital inflow and driving component of financial development in many great creating nations. So we just want to create a model to detect that the phrase is the total phrase or not. Yeah, and as we know that the expected phrase corresponds to the creating nation, it should be developing countries. All right. So up we have try to find how to create a model to detect the total phrases. And what we have in hand right now is the data set. So we have two kinds of the data set. So the first one is the list of the data set. The data set of the what are the total phrases that are annotated by the contributor of the annotator to annotate what are the total phrases correspond to the expected phrases. And in order to for our model to learn, for the machine learning to learn, we need the context that contain the total phrases. So the next data set we got it from another paper from Balov et al. In 2021. It's they have the paragraph that extracted from the Wikipedia or account thesis, and they extract those paragraphs, and then they use the Spinboard and the Spinner Chef tool to generate those kind of data set. Those kind of paragraph, and then when we try to detect whether those paragraphs contain the total phrase or not that we mentioned in the data set number 1. So we got a list of the context that contain the total phrases for our machine learning to learn. Okay, so these are our techniques that we use. So there are two kinds of the techniques. So the first is the machine learning classification, and the second one is the cosine similarity computation. So for the classification task, we try several classifiers. So the first one is the random forest classifier. The second one is the perceptron classifier, and the last one is the, I can say, the popular or the state-of-the-art classifier is a transformer-based classifier. And for the second computation is the cosine similarity computation. We just want to know the similarity of the two words. And in this context, we try two different word representation because we want to measure how the different or how similarity are the words. So we need to use the word vector representation, and there are several kinds of the word vector representation, or we can say the word embedding. And we in this experiment we try with two word embedding. So the first one is glow, which is the pre-trained embedding, and the second one is the bird, is the I can say dynamic word embedding. So for example, I want to mention about glow or the difference between glow and bird. The example here, if we try to know the similarity of the word bank, like the bank in the context river bank and the bank in the context bank account. So these two banks has different meaning. And if you use glow, these two banks have the same meaning. So it's the similarity is one. And if you use bird, so these two banks have different meaning for the bank in the river bank and the bank in the bank account. So the similarity is only 0.6. Okay, so these are the results from the experiment. We just try with the different classifiers and try with the different data set. We try to and the best result is to use the transformer-based classifier. And yeah, and we also use different kind of the data set like the 5 gram. We try to split the sentence into five words, or sometimes we try to train our data with the whole paragraph. And we see that the data, I mean the model that they train the data with the 5 gram and do the transformer based yield the best result among of the classification tasks. And then move to the second experiment is to use the cosine similarity comparison using the globe or bird. So as you can see, the box, the box plot on the left hand side, we use the bird word embedding, and the right hand side we use the globe word embedding. And as you know, if you use the bird word embedding, we don't see the difference between the expected phrase and the total phrases. So for example, I compute the cosine similarity of the two phrases. I mean the phrase that has two words, for example, like the New York, or creating nation, or man-made brand power, or something like that. So I try to compute the cosine similarity between New and York. Yeah, this is how we do the cosine similarity there. So for the use bird, we don't see any much difference between the expected phrase and the total phrase. But if you take a look at the glow word embedding, you can see the difference between the mean of the expected phrase and the total phrase. We can see that it's around 0.3 for the mean of the expected phrase, and 0.1 is the mean of the total phrases. So we can see the result from the globe embedding from the experiment. Yes, because it is just the investigation how to differentiate or identify what are the total phrases. So the outcome, if we can create a model that can detect the total phrases, is have the user or researchers or some readers to avoid the fraudulent papers. And for now, we only do it in English. So in the future, if we can do this, complete this model, we can adapt it to other languages like Khmer, Thai, or Lao, and something else. Okay. So yeah, the outcome is it's just a model that can detect the machine generated text, and even the source code and the data is available online. So if anyone want to adapt or improve, or you want to learn or investigate more about this kind of research, you can take a look at the data and the code online. So the conclusion is, as I mentioned earlier, is the transformer-based classifier. It's outperform other classifiers, and the cost. Sorry, and the cosine score using the pre-trained embedding perform better result. And because our data set is small and we need much data set for our training, so we need more data set, a bigger data set for the training. And one more thing, if we could try or other experiment like or other classifiers such as SVM or naive-based or something like that, we can see the difference. And for the cosine similarity computation, if we can try with other words embedding such as Wutitiwatchai and FastTech, so maybe we can get the different or better result. And thank you. And these are the references. And if you want to see the detail or you want to see the code or the data set, you can see go to the last paper. Yeah, like the investigating the detection of the total phrases inside scientific literature. And that's it. And here are, thank you for your attention. And this is my contact. Yes.
Thank you.
Thank you.
Right, we have time for questions. Anybody wants to ask? There's a question in the back, please.
Thank you for the presentation.
Thank you.
Two questions from me. So the first one is, is this definition of tortured phrases, they're only applicable to noun phrases? Because it seems like from all the examples that you gave, they're all noun phrases, right?
Oh, yeah, I can say it is the total phrases that we have. And yeah, actually, it's mostly noun phrase. Yeah, because when the annotator, they try to annotate, they try to find it from the paragraph or the scientific papers, and yeah, I mostly noun phrase.
Do we see anything, like tortured clauses, or something that's not uncommon? It's something that's a little bit uncommon, but it's not just a noun phrase. Do we see that as well?
I'm sorry, can you repeat the question, please?
So, so can we go beyond noun phrases? Uncommon way of writing certain clauses. Do we see that in machine-generated papers?
Yeah, I think it can go beyond a noun phrase, but for now, because of the listed total phrases, yeah, I can figure out that they are mostly noun phrase.
Got it.
Yeah.
So I guess second question is more general. These days you probably know about GPT-3 and all these large language generative models, right? Which can generate articles without actually using all these tortured phrases, right? It looks very natural. Any thought on this?
Yeah, because of some research, they also mentioned that it's really human-like text.
Exactly.
For example, like GPT-3 or something like that.
Yeah.
But in some small errors, it still contains, I can say, the total phrases. That's why to avoid those kind of errors, but that's why we want to create a model to detect the total phrases.
Got it.
Yes, thank you.
Thank you.
Thank you.
All right, I think that's sort of all the time we have. So we'll move on to the third topic for today, which is spoofing detection in automatic speaker verification. All right, and our speaker is Kasama Kongsmak.
This one, okay. Agus
Good afternoon, everyone. My name is Sarun Sumriddetchkajorn. I'm from NECTEC, Thailand. And today I will present my work. Instead of my team, I will present the work that is cooperate between NECTEC, SIT, and JAI from Japan. So the title of the work is a spoof detection for automatic speaker verification. Okay, let's go on. Why we focus on automatic speaker verification? So in here, the application that about the speaker verification is rising in using to verify person and to verify speaker. They may use the physiological features such as iris, fingerprint, ear, or DNA. Or sometimes they may use the features such as behavior, like your signature, how you walk, or your voice. So in our work, we focus on voice. And why is this voice? Because our voice is now is more using in many sections, like for technology domain or financial domain. So it's quite important and sensitive to verify. So in here, let's say we have the speaker verification. So when someone wants to verify, here, John wants to claim this is John. So speaker verification will just whether this is John or not John. So if he is John, he can continue doing something in name of John. So what is the problem in this system? So the problem is the spoofing attack. That means it may have someone try to make John voice, or some tool that synthesis John voice, or some conversion program that try to make John voice, or even the replay of John voice. So in this case, we need some tool or some countermeasure to detect that kind is the fake one, not the real John voice. And so in this speaking, I want to invite you to participate in our project. In here, we want to make the spoof detection. So here we already have an ongoing project that we already running. So on our ongoing project, we check the contribute of a white part and non-white part for spoof detection. And also we check the pathological feature for deepfake detection. So on the work that we will going to find partner by using the platform from NICT, that is the ASEAN IVO network here. I want to recruit the partner to join our work. So do something more about the spoof detection. So in here, we will investigate the significant feature for spoof detection. And for each feature, we also try to check the contribution of voice and non-voice for each feature. Also, the pathological feature that we already use for deepfake detection, we also consider to use it for spoof detection. So if we can use all of this, so the error detection of our spoof system will decrease. And also we also consider to use to make the multilingual spoof detection. And okay, let me introduce some of our work. So in here on the table on the above, you can see that not only voice that contains spoof feature. So you see that if we use only voice, the error detection of a system is still high, but the spoof, the feature to detect spoof is contained in non-voice. But if you use the word utterance, the error will decrease. So in our work, we check the contribute part of voice and non-voice. So you can see that when you use the different percentage of voice and non-voice, the error of the system will decrease significantly. So here is our work that we already checked. And we also check for audio deepfake, that the deepfake is using some kind of speech synthesis tool. So this tool can make the voice with high quality. So when we want to distinguish with the human voice or deepfake voice, so in here we use this feature to identify. So in here we also try to use this feature to check the speed spoof detection. And okay, let's say our idea for proposed method is instead of go directly to automatic speaker verification, we will add the spoof detection here. Whereas if the fake voice will eliminate from the system, just only the authentic voice that's go to automatic speaker verification. That means the security or the system will be more secure. And in order to do the spoof detection, in this work, we will check the significant feature that important for spoof detection. And we also check the percentage of voice and non-voice for each feature. And also we will investigate the pathological feature. And finally, we will minimize the error detection. And when we minimize error detection of the spoof detection here, the accuracy of the ASV system will also better. So, and we also plan to study multilingual for spoof detection. So in here, when we expand our work from spoof detection here in the big picture, we can see that we will investigate so many features here, and we also investigate voice and non-voice of each feature. And we may use the different classifier. And lastly, to improve the error, we use the fusion here by using the Dempster-Sheffer theory here. So in here, we may add the fusion here with the different percentage of the voice and non-voice or different feature, and also different classification. And how can we know that our system work well? They have the baseline that have the challenge that about the automatic speaker verification and spoofing countermeasure challenge. That this challenge start from 2015 and is had every 2 years. So if we want to know our method it work or not, we can compare with the baseline from that challenge. And in order to make the new data set that we intend to make the Asian member state language. So in here, we intend to use the common voice data set and make it to the data set to check for spoofing detection for the language inside the Asian member state. And so when we talk about impact, so it had also the direct impact and indirect impact. So we can say that when we improve the accuracy of the ASV, when we can use our knowledge all that about the feature or pathological feature, then when we directly improve the accuracy of ASV. And for about the data fusion beside the ASV, it can use for another application as well, that is indirect. And when we can make the data set for spoof detection about the language in the Asian member state, so it can public for another group or another person who interested in this work to improve the accuracy or try to investigate more in this field. And for social impact, if you can improve this system, so this system mostly used in the banking application or an online shopping platform. When you improve its accuracy, that means the security of the system will be more better. So in here, so from our work, the outcome and the output that we expect from our work. So from the thing that we explore the knowledge, so we intend to make it as a scientific, as a publication or prototype or patent. And also, as I said, we can make the database for sharing to detect spoof detection. And for social, we also intend to make some kind of application. When you input some voice, the application can tell you whether that voice is the real voice or is the fake voice. So the fake voice is may synthesis voice or replay voice, or someone try to mimic the voice of another person. And we also expect the collaborative between Asian countries that we can make the data set for multilingual spoof detection. And let's go on for my conclusion. So the problem that we want to solve in this one is a spoofing attack in automatic speaker verification. And our target, our aim is we will make the spoof detection system. So in order to make the spoof detection system, so the work that we must do, that we must investigate the significant feature that have that's important for a spoof detection. And also we must find the optimal percentage of voice and non-voice for each feature. And we also investigate the pathological feature. And we try to minimize error detection by using data fusion. And we also try to make the multilingual spoof detection. That is for our target. And the method that we use, that when we find the significant feature, we use the significant feature, we find the optimal voice and non-voice for each feature, and we use pathological and we use data fusion. So finally, we will get the system that low error rate that make the effective automatic speaker verification. And for scientific and social impact, we want some kind of publication, patent or prototype, and we will have the data sharing among the ASEAN member states to check for spoof detection. And that is all. So if you're interested in, I'm sorry that I forget to put my email in this presentation. So I'm still be around here if you intend to join us. So you can come and talk me. Thank you.
Right, we do have some time for questions. Anybody wants to have a go? Yep, there's Mr. Somnuk.
Thank you for your talk. Interesting topic. At the moment, do you have a good idea on what are the good features for spoofing detection?
We just investigate some feature and not really all feature because it have many. So in here, when we show that ongoing work, we investigate only MFCC, and we also intend to investigate the pathological feature. We also see some kind of characteristic that if they have how to say, if the fake voice and the real voice is characteristic is quite clear. So right now I cannot say which one is the best one, so we have to explore more.
Okay.
But the feature that are correlated to how your vocal voice is produced, the sound is more important, I think.
Thank you. I have another one. The application of this work meant to be the voice speak over the phone, right? Speak over some, not face to face, but
right now, yes.
In that case, the voice itself must go through many other processes along the way.
Yes.
Will that actually make things harder for you?
But they have some kind of characteristic, even though it's the record voice, but they have the characteristic that you can identify some different. So right now we are not like a physical access to just speak to the system directly, even though on the experiment right now we use the record voice.
One more question, maybe. Yep, there's a question there.
Thank you. Related to the first question, I think, do you have some sense of, this feature, are they sensitive to language or gender or age or accent even? Any
right now, not yet.
Okay.
Right now, we investigate only some that the data set that they are not depend on and only English language, and they are not categorized about the age of the speaker or gender. Oh, gender is classified different gender. For female, for male is more difficult to detect.
Yeah,
For male, it's more difficult.
yes, because the tone is, but for female is some kind of swing.
All right.
Yeah, so we try to investigate separately male and female. You to try that.
Right.
But for age category, not yet.
Got it. Thank you.
Hi.
All right, so I think that's all the time we have for this session. So let's thank all the speakers once more. And now we'll go for a 10-minute break for coffee outside. And please be back at, 2:55 so that we can start on time. Thank you very much.
fever is 40% without treatment. So like a countries so have a very lacking on the access for the medical care, like in the world map, so in like India and so the Nepal and for the Southeast Asia, and then we can see the daily rates. So the all the Southeast Asia from the orange to the red zone, right? So we need the devices, portable devices, a simple, cheaper, and very accurate, and digitalized. That means to be able to tracking. That means to track when the outbreak is happening. So what the problem with the current system? So as shown right now, the gold standard we call as a wider test. They using a blood to cultures, but they need a complexity and need a time statement for the culturing. And most of the testing is a qualitative method. So what our target in our group? So how the possibilities? They mean to convert from the qualitative method approach toward to the quantitative method. So as shown in this slide, so if with the blood culture, they take about the 3 to 5 days and have some misdiagnosis between the typhoid fever and that with the other diagnosis fever. So what we are target for our project, how the possibility, the utilize of the electrochemical sensing platform, and then be able to convert the data, that means from the qualitative data to the quantitative data as a current signal, and be able to make it the system be the digital form, so be able to integrate with the IoT, the enable of the IoT system. So we based on that, so we hope that can be more specific and the fast detection. So that can be the earlier treatment. So that can be, we can know which have the outbreak. So it can be, that can be more faster to make the action. That means for the, not only for the detection, but be able to do the monitoring. So what we are propose a method. So as shown in this project is collaborations between my side from the engineering, and then we work with the Institute of Molecular Medicine that from the medical science. So how they come to the engineer the protein and DNA that have a specific, not only for the infection patient, but now we focus on the infection patient and also with the carrier. In Malaysia, we have some problem for the food handlers, right? So some they have be detect as a fever, but we cannot detect other day as a carrier. So we focus on the two method, two detection, the infection patient and also for the carrier. Then we do the yeah. Oh, really? Yeah. Okay. Sorry. Okay. Let I continue for our proposed method. We have a group from the Institute of Molecular Medicine to help us to develop the protein. That means for a probing for the carrier and also for the to detect a carrier and also in the infections. Then in our group, so we develop our own electrochemical sensors using the concept we call as the lab on printed circuit board. So what the uniqueness of the sensors? So we do fabrication using a standard how we do for the circuit fabrications, right? So next, so we do the modifications on the working electrode with the graphene oxide with the chitosan to improve the surface area of the working electrode, so that can amplify the current signals when the probing and the target is meshed, so that can be the hybridized, so that can affect the surface area, can reduce the ionization transfers between the target to the electrode, so that reduce the value of the current. That's how we convert from the qualitative to the quantitative data, right? So, and then, so how to minimize the sample? So we do the integrate with the microfluidics. So then we do the integrated with the microfluidic, so that can minimize the sample, so that can be make it the system make it a fast detection with the minimum amount of the sample. Finally, we do the integrations with our own fabricated microcontrollers, so that may make the system be IoT enabled, so that can be have a Wi-Fi connectivity, and then can be the integrated with the smartphone. So this is what our current prototype. So this is a project, the ongoing project with our group and the industry partner start from Biogenes. So we collaborate with as a partners. So this shown how the prototype of the sensors. So how we be able to modify for the readers. So this the app the sense. So how they can be paired with the smartphone. So the Android OS. So the good if so that can be the GPS. So be able to detect which the detection is happening. So but now so we be able to be the system, make it as a quantitative. So as on that how this as a current signal series. So that's what we are current prototyping, the current prototyping, and also I share also the video in the system. I mean for the demo of the prototyping. So the good if the impact if for the scientific and the technological, so we developed the highly sensitive quantitative the salmonella detections in using the electrochemical transducers, and we developed our own design, the own fabrications, and then using the concept of the lab on printed circuit board. Then by modify the working electrode with the carbon-based nanomaterial, we use the graphene oxide and chitosan. So we amplify the signal for the current. And finally, we show how the possibilities for the salmonella as a IoT. I just call as the Internet of Salmonella Things. I mean for the salmonella point of care diagnosis. For the societal, so when we have the data, so I mean we be able to tracking with have the outbreak is happening. So that means we can do a fast action, fast alert, so that can be for the tracking for at the local communities. For the collaborative, right now we are working with the Institute of the Medicines, from Inform and the MOH, the Ministry of Health, and also with the startup company that mean to do for further prototyping. And then of course we have the engagement through this grant. We have for the previous grant we work through the CREST grant and also with the local community in Kelantan. So that's what the impact. So how we be able to convert from the traditional technique, that means from a blood cultures, from the qualitative data towards to the lab on chip, but we modified to be the lab on printed circuit board with the enable of the IoT, so that can be a further improvement with the cloud analysis. That means for the deep learning analysis. So right now, our data, we saw the prototype be able to communicate with the Android-based smartphone, and then hopefully that can be more impact. So for example, like for the in the rural area, so this device can park at the rural clinic. That means to have a fast. That means for the typhoid fever monitor. So that one of our current output. That means from the outcome from that fabricated sensors. So we achieve the LOD for the DNA about 0.076 micrometers. So that how the output from the portable MCU. So it means for portable video. So that for the DNA type. So this is what we have for the protein. We have worked with the YNCE and also the hemolysing protein. So that we have achieved right now with 1.132 microgram per milliliters. So this still in a progress to improvise the sensitivity using the ERS measurement technique. So that the current outcome that we have. So the portabilities of the Internet of Things enable for the salmonella detections. So the conclusions, so we improvise the miniaturization and the limit detection for the electrochemical sensing for the salmonella detections. And then we put the concept, our sensor not only detect the infection of patient, but be able to detect the carriers by the engineered the protein with the developed by the Inform. And then by the integration of the IoT system into the biosensor can be promising diagnosis tool for the digital-based salmonella detection requires the Internet of Salmonella Things. And then so this platform also can be interchangeably with the other bioreceptors, just do the modifications on the probing. And then as a future work, we hope we can integrate with the cloud services and machine learning to create the prediction system for the behavior of some salmonella outbreak in local communities. With that, I end my presentation. Thank you.
Okay, thanks. We only have 1 minute for one question, perhaps. Yeah, I already see the hand raised up. Can somebody send the mic?
Thank you very much for the presentation.
Thank you.
So this kind of a lab on a chip device. Is there any way we can convert, because I think currently it's on a micrometer scale. Is there any opportunity if you can convert it or miniaturize it in nano size dimension?
Okay, because that what we are propose, because the target, if we want to propose the cheaper and the simple the diagnosis system, that's why they have the pro and con. So the first, because the lab on chip, is more to the silicon, so it can be able to miniaturize up to the nanometers using the semicon process fabrications. But what our target here is, we want to have a system able the simple but easier to do the fabrication using a standard the printed circuit board. So the uniqueness of my project, we approach on the lab on PCB, lab on printed circuit board. Then to answer your question, I mean, how possibility to miniaturize, is it up to the nano, is still depending how the limitation of the printed circuit board fabrications technologies. And then some sensors because
we gotta take the question outside offline.
Okay.
Yeah. It's getting longer and longer.
Thank you.
You have more things to share. Thank
thank
you
you.
for the presenters.
Right.
Now we welcome the second speaker to come forward for the title of his project, Combining Controlled methods and UNET to segment and locate abnormalities on coronary arteries image. Can we have the presenters to come forward? Yeah, okay. Just a reminder to the presenters, when you are excited presenting your work, please also listen to the bell. We actually hit a few times. I think it didn't get through to you guys.
Good afternoon, everybody. I'm welcome from Saigon University of Vietnam. So I'm so honored to introduce. This is my project. Is here about total. Is segmentation. This is a coronary artery image and detect. This is abnormalities. This is a branch of a big project about we would like to use a combined controlling method and UNET to segment and locate by this is a new algorithm to find out. So it is in 2019 in the world over 17.5 million deaths. This is over 32% in global deaths. It leads the cause of the death in the group is cardiovascular disease. Is it some problem in the vessel in the heart? If we have a problem, this is abnormality. So we have a accident. Is it right now? Similarly to that, we don't know happen in here. These are reasons. This is come from the hospital. Is it a doctor requires about how can they detect it early by X-ray? If they know it is in the early by the X-ray image, these are golden standard time they can rescue this pattern. And from the image from the video, they scan this pattern. How can we detect and locate and warning to the doctor where is this abnormality, nearly help them to solve this problem. So this is a problem the target. We have two problems. The first from the image, how can we know where is the coronary artery image? This is how we can use some technique or some method to solve by segmentation. The second problem, and we detect the abnormality to locate these abnormalities on the vessel. So from the problem, we suggest to some method. The problem one, from the vessel from the coronary artery image, it is a contrast. It's the same with the vessel and around the vessel. It's near the heart. So this is a problem. It is difficult to segmentation. So our group to suggest to enhance this is the vessel by control it. After that, we build is a UNET. This is a kind of the deep learning. This is improved by CNN to get this is output. This is the image. Coronary arteries is segmented. The second problem we solve by we have three steps in the head. From the input is a problem we detect abnormality is the output from the segmentation, and we pre-processing and find candidate. Finally, we confirm this is who is the candidate is the abnormality, and we get output. The detail from the problem problem one proposed method, we have a two phase. The first phase we enhance by control it. We use the control it. This is a method to enhance and adjust coefficient and control it and reverse control it transform. We have the result. It's enhanced. The second phase we segment by UNET. UNET is deep learning This is improved by CNN. It is very, very good for medical image to processing. With the second problems, we suggest three phases. The first, we are pre-processing. The first from pre-processing, we smoothing. We make a smoothing the ad. When after the result, we segmentation. This is a boundary. Is noise somewhere. This is a big problem. So we must to make it smoothly. The second, if the versal is direction is so different. So it's a big problem if we move to from the pixel to pixel on the egg. This we cannot detect what happened inside. So this equivalent we rotate. This is the versal to horizontal versal in make easy to solve. The second phase, we detect candidate by we move on the upper and lower there's a boundary, and we find out who is the by the direction and the angle, what is a bit the area is the candidate. And the last phase, we form the candidate, we calculate the diagram, and we confirm who is this where is area we can sure is abnormality. So this is our research in back to serve abnormality detected by new method. This is a problem come from the hospital. This is the doctor requires to help them to solve this problem. I think it is if we can solve this problem, this is the almost hospital to need to early to detect this is the abnormality. The second, we would like to have a cooperating to collect more data because it is data from the hospital, from the medical. It is very, very important and difficult to get the data because some license from hospital, license from the government in here. And we can have a cooperation and we can connect to publics together. These are our result, and the hospital can use the result. This is the outcome. It's my project, a new solution. The second, the public data. If we can collect data in Asia, from Vietnam, from Indonesia, Malaysia, Brunei, we can collect it and we publish to researchers over the world can improve. This is more about, and we have a cooperation in Asia to work together. So this is a target. This is detect the abnormality on coronal artery image. A method we use a form control it, combine with UNES and design more about new algorithm to detect. And the third is the scientific and society impact. So this is the problem and how doctor and how get more about cooperation in Asia. So thank you very much for your attention. This is my email. If you feel is it my project, my topic, is it attractive, you can connect me and we work together. Thank you very much.
Thank you to the speaker. While you make a record, we have 7 minutes left for question and answer. So anyone?
Pattern. Three-dimensional also, this one unique segmentation.
Yeah, we work at 2 dimension and 3 dimension. Yeah, 2 and 3. Yeah, because if we take a picture, it's a 2 dimension. If we take a video, it's a 3 dimension. But with the 3 dimension, it's more difficult than 2 dimension because if the patient to go to hospital, they scan, this is the versal, because the doctor, the hand is not handle is they are flexible. It is a move around. It is some signal and some result is different. Yeah, you.
I have no question. only one recommend, maybe.
Yeah, thank you.
Because in my opinion, this research is on the medical area. So that I think it's better to have one doctor in your research team, because I think for defining the abnormalities in the image, it's better to have one doctor.
Yeah, thank you very much. As I introduced, this is a problem come from the hospital. So this is the reason is some doctor to help us.
Okay, any more hands?
Okay, thank you very much. I am Khairul Anwar from Telkom University, Indonesia. I have two questions. So the first, would you please clarify what is the current method? Yeah, and then the existing method, I mean, and then what is the difference compared to your new algorithm? So this is the first question. And then the second, here you use the two phase, right? Segmentation and detection of the abnormality. So for the detection of abnormality, I think we can use a computer, for example, to detect. But for the segmentations, or both, or you are using computer, image obtained from the doctor, and then you analyze using computer. So this is my question. So please clarify if my question is also wrong. So please clarify. Thank you very much.
Yeah, thank you. The first questions you asked me about. So I answer the second because I can remember exactly. This is the second questions. This is the I design a new algorithm to solve this problem, the image on the computer from the computer design computer. The first phase we use controlling to enhance, and the second we design the unit. This is different deep learning to segmentation the image. The second phase we must to design more about algorithm to locate where is the abnormality. So as you know, it is this resource. This the third phase in this problem. You can search in the internet. We publish more about 4 or 5 articles. Yes, this is now. We would like to make it better. In the past, the last year, we designed a different method. Accuracy nearly about 87%. It's now we hope it is more exactly. Thank you.
Okay, so good afternoon. It was interesting what you're presenting. I just want to know, because to follow up on the questions on the 3D and 2D, right? So your existing methods, is it already can do for the 3D approach? And if it's 3D, are you still using the same segmentation approach that you use for the 2D?
No. If we use the data is 3D, it's different from the 2D. Because if the 3D, if it, the layer in the first layer and the second layer is not the same as the axis Z. Yeah, they move the axis Z in the space.
So what segmentation do you use for 2D and what segmentation do you use for 3D?
So I think it's my opinion, we must to adjust the chase is the axis. We can use 3D unit or 3D CNN to solve.
So you haven't applied on 3D yet?
Yeah, not yet.
Okay. I think there's an area that we can actually talk about.
Yeah.
Okay, with that, I think that's all the question we have. Thank you so
Yeah,
much.
thank you very much.
We will now move to the third presenters for the title of AI-based control of lower limb rehabilitation device for elderly people.
Assalamualaikum and good afternoon. So I'm Asnu Juraiza Ishaq, and here is my committee member, where Prof Wada from Kyushu Institute of Technology, QTech, and Dr. Wan Alia from the Faculty of Medicine. And the others member is Dr. Azura, Dr. Mamahe, and Saomi Shin from same department with me, which is under Department of Electrical Electronic Engineering. So this is my proposed title for the future research, which is AI-based control of a lower limb rehabilitation device for the elderly people. So currently, I'm is a research fellow under the My Aging, which is under UPM. We have a Center of Aging, and then we have opportunity to gain the data and do the collections by helping from the director of My Aging and also Dr. Wan Alia. And here is outline. Before I go further on the proposed method, I would like to discuss about the my past research, okay, and also the current research, where my past research on the ankle rehabilitation device also, and this is focusing on the signal processing, okay, pattern recognitions, and then the EMG system we managed to develop by ourselves for the My Aging Center, for the use for the postgraduate research, and then under the ankle rehabilitation, we just a minimal use AI method for type of motion, okay, for the ankle motion, which is dorsiflexions, plantar flexion, adduction, and also the abductions. And then we move to the current research, which is we currently manage to do this one, focusing on the development, knee rehabilitation development. As you can see that we're not integrated yet the EMG signal, force signal, and then the monitoring that we managed to develop is not real-time data. We need to calculate the power of the signal from the EMG signal and also the force, and then we transfer it to the system using the cloud server. So this is our futures research that we like to propose, where the ankle, the knee rehabilitation device will be integrated, combined, and we want to control monitor the motions, the improvement of each motions based on the EMG signals and also the force signals by applying the AI method. Okay. So the background of the studies or the research, it measured the percentage of elderly populations aged 65 and over, increased from 7% in 2020 to 7.4% in 2021. So elderly population have problem in neurological disorder and chronic disease. So as you can see that in Malaysia, the population for the elderly is increasing. And then because of the knee pain by traffic incident, osteoarthritis, and also the ACL strain or tear. So non-surgical treatments such as the physiotherapies or exercise are first recommended to knee osteoarthritis patients before opting for knee replacement surgery. So and then the joint stiffness and decreased knee range of motion have been reported following surgeries such as total knee replacement, ACL reconstructions. So therefore, the range of motions exercise is crucial in treating knee osteoarthritis and also the relieving stiffness after surgery, restoring ROM, the range of motions, and improving muscle strength of the patients. So the target of the research projects is develop an intelligent control of the knee rehabilitation device for improving the range of motion and muscle strength of patients. So this is the futures or the proposed that we plan, okay, where it cover under the objective 3, okay, objective 3. So the first objective is to investigate an EMG based and force control for analyzing human disability and observe the improvement of the rehabilitation processes. And then to develop a rehabilitation device, this one we done, okay. And then to design an effective control using a intelligent method for identify the unique EMG pattern and also the force pattern. So this is ongoing, okay. So the methodology or the proposed method. So the first one is stage 1, which is data collection and characteristic of neurological disorder, EMG and force signal, where currently we have the ethical approval, EMG and also for the ECG. So it will expire, but we will communicate through the Faculty of Medicines to apply for the next projects. And then this is the flow for the signal processing method. So we need to go further with the pre-processing, which is for the enhancement of the data, winnowing, feature extractions, feature reduction, which is for the feature selections, and classification. So for this moment, we minimal apply the AI, but not really done yet, because we are focusing on the development of the knee rehabilitation device. So the stage 2 is a model simulation and fabrications. So we managed to design the knee rehab device by using the AutoCAD, and we did some simulations on the types of motors and also the gear. And okay. And stage 2 model simulation and fabrications, where after we design the mechanical the structures of the knee rehabilitation, we need to do the simulations in order to test all the joints and to test the motors, and also to make sure the motor run properly based on our speed, target speed and target angle. So we need to have a good control there. So and then we propose for the current research, we use the PID to control the speed and also the angle for the knee joint motions. And therefore, okay, we need to do the further works on the future work 1, where we need to have an optimal gain. We can use the optimizations algorithms, or we can use the fuzzy logic and so on. So for the, and then for the, from this one too, we can propose for the second future works, where we can do the mapping or compare the previous EMG signal before the training started with the current EMG after the first trial or the several trial to control the motor speed, because we need to know the improvement of the muscle. So that's why we need to have a comparison between these two EMG before and after. So, and then stage 3 control development, EMG, force control system and intelligent method. So this is under the futures work 3. After we gain the signal, okay, we need to do the signal processing and then windowing, okay. And then from there we extract the features, okay. And then we apply, that's why we want to apply the force signal and EMG signal, and then we calculate the correlation. And from there, we can do the real-time data monitoring system, okay, for the future work 3. So the output is the monitoring system. So the currently that we managed to use the, we managed to display the bar chart, but this one is not the real data monitoring system. We calculate the EMG powers from the EMG signal, and also the angle from the knee and also ankle joints. So that's why you can see only the bar chart there, okay, instead of the signal. So, and then the impact, the EMG-based control can be implemented on rehabilitation device or the therapy machines, and trainer tool to new therapists and host and health officers. Open EMG database offering different kinds of lower limb joint motion, which is covered for the ankle and also knee. Decision-making system with AI implementations. So the conclusions, so this is the conclusion that from the current research achievement. So knee rehabilitation device was designed and selected. Control system was designed based on the PID control. And also we also did the experiment and tested were carried out. And then the simulations, again, the simulation for the PID controller design in MATLAB result, we finally find out that the low overshoots and zero error between the set value and the actual value. Okay, and then the future improvement is based on the future work 1, future work 2, and future work 3 that I've been explained before. So this is my plan for the connected projects: medical data signal and data analysis, which is cover the signal processing and also the image processing. AI-based control development, healthcare monitoring system, actuator rehabilitation applications. So thank you.
Okay, thank you. We welcome questions from the floor. 3 minutes.
Done the past research, right?
Yeah.
Yeah. Okay. And then now the stage is how many percent now?
On the development rehab knee device, okay, knee device, we already complete, okay. This is our controllers on the right side, but without the AI. And then we have a force sensor EMG signal been also done, and then we done the knee rehabilitation device also, but without the AI.
So based on the results, you know, any university, hospital, university, you know, work together with your project?
Okay, so far it's Dr. Wan Alia. Dr. Wan Alia is from the Faculty of Medicine, where we from the HP UPM, Hospital Pengajar UPM. So we have a Hospital Pengajar UPM. So that's why in ethical approval, we not very difficult because we know the pattern, because this is my second time to apply for the ethical approval.
So I would suggest for you to involve industry, you know, so that end users, you know, finally, and then you want to commercialize this, for example, we need industry to be part of the work. Okay, thank you.
Okay, thank you.
Okay, any more questions? So maybe I just ask one. Since a lot of work has already been done, you're just talking about missing the AI parts to go in. So maybe one of the plan you could have is to do some benchmark with those equipment out there. And maybe we are targeting some low cost, which is more affordable. Yeah, maybe some thoughts along that line.
And also friendly use.
Sorry?
Friendly use.
Yes.
This one, yeah.
Yes. So a benchmark on that will be very useful
Yes,
with those
yes.
in the industries.
Yes, I have a question.
Yeah, okay.
Yes,
please.
so yes, okay. Thank you very much for the presentations. To the best of my knowledge, your objective is to develop an intelligent control, right?
Yes. Yeah.
Yes, and then in some slides you saw that the feature extractions is based on time and frequency. For the case of based on time, maybe it is easy to understand. But would you please explain what is the feature extraction based on frequency?
Okay.
Okay, and then the second, would you please explain what is the difficulty of this control system? And then what is the connection with the EMG? Because I cannot get from the presentation.
Oh,
Thank you very much.
Okay. The first one, the first one is related with the pattern recognition, based on the time domain and frequency domain, right?
Yes.
So the time domain, as you can see that this is where my previous here on all the time domains features, and based on the frequency domain, that's why we not manage explore yet. Okay, but as I can suggest that we can apply the like the convolutions method for the frequency domain, and which is under the CNN, and also for the second questions related to.
Yeah, what is the difficulty in this design?
Okay.
Yeah, and then what is the connection with EMG signal? Yeah.
So so the difficulty on to control the monitor the speed of the motions for the knee and ankle motions, because every treatments that we example that like knee ankle that we did, so we have 10 sessions or 20 sessions based on the difficulty of their joint. And let's say 10 sessions. So the 10 session we need to control the angle. So control the angle and also to control the speed. So to control the angle and control the speed by manually difficult to monitor. Okay, and then we apply the PID. So then we can map their pattern, the signal pattern from the EMG. Okay, and the force, whether they have how many different percentage. Okay, so that is the difficulty. So why implement the EMG? So the EMG, as you can see that here, EMG signal before and after. Okay, we want to do the mapping. So the first treatments, we can see that the strength of the EMG signal is very low, weak. Okay, so and then how is the improvement for the second after we apply the therapies based on we already control the speed and the angle. So the pattern there, whether EMG signal or the force signal should be increasing same level. Why I explored the EMG and also the force sensor, because of the, let's say that example just now about the industry, we want to see which one is sustainable and also the very low cost. Okay, so as from my opinion that force split, we apply the force split for the minimum angle that should be fine compared to EMG.
Okay. Thank you very much.
Okay, thank you. I think more discussion can continue after this. Thank you so much. This concludes the sessions 5. We have 2 more to go.
Good afternoon, honorable person, ladies and gentlemen. Let me introduce myself. I'm Kemasuk from University of Computer Studies, Yangon. Today, I will do as a chair for the session 6 ICT related applications. There are 2 presentations in our session. Let me invite Ms. AAR from University of Computer Studies, Yangon for the presentation.
Good morning, everybody. I'm AAR. I'm from University of Computer Studies, Yangon. Today, I would like to talk about our proposed system. The idea is end-to-end speaker suite diarization with self-attention for conversation. This is my outline. I had divided my presentation into 6 parts. I will take 15 minutes for my presentation. If you have any question, I will answer at the end of my presentation. Let's now move on to the next slide. Firstly, I would like to talk about the background of the proposed system. Speaker diarization is a task-to-level audio or video recording with classes correspond to speaker identity, or in short, a task to identify who spoke when. There are 4 main components of speaker diarization system are speech segmentation, and then embedded feature extraction, and then clustering and resegmentation. This system can be useful for transcribing meeting, classroom speech, or medical interaction. And it also helps AI and human understand who is saying what throughout the conversation. The main problem will be solved by speaker diarization is to determine the number of people involved in a meeting, or either in the meeting, broadcast news, or telephone conversation. And moreover, the speaker diarization solves the problem solving or indices and retrieval-based system, such as multimedia, indices, and speaker, indices and retrieval, etc. And it is also to support low-resource languages. That is an important pre-processing step for many speech applications. Now turn to the next slide. I would like to talk about the target of the system. Speaker diarization has been mainly developed based on the clustering of speaker embedding. Clustering-based approach has problems such as not optimized to minimize diarization error directly and cannot handle speaker overlap correctly. So, end-to-end diarization in which a directly outboard speaker diarization result given a multi-talker recording were recently proposed. In this result, enhance end-to-end diarization by using set attention block instead of by LSTM block. In contrast to by LSTM, which is conditioned only on a previous and next hidden state. Self-attention is directly conditioned on all the other frame, making it more suitable for dealing with the speaker diarization problem. To achieve good performance and proposed method to be significantly better than the conventional by LSTM-based method. Speaker diarization is useful because it makes to increase transcript readability and better understand what the conversation is about. Now move on to the next slide. I would like to talk about the proposed method of the system. Typical speaker diarization systems are based on the clustering of speaker embedding. For instance, I-beta, D-beta, and H-beta are commonly used in speaker diarization tasks. I-beta means a new low dimensional speaker and channel dependent bit, which is conditioned only on the simple factor analysis. And then D-beta is the average activation from the less hidden layer of deep neural network. It is unlike I-beta. The I-beta framework is the Gaussian distribution. And then H-betas are extracted embedded features better from deep neural network, which provide speaker-specific representation and improve speaker recognition when large amount of training data are used. So this is about the speaker embedding of features better. And then these embedding of short segments are partitioned into speaker cluster by using clustering algorithms such as Gaussian mixture model, agglomerate hierarchical clustering, Minkowski clustering, K-means clustering, etc. This clustering method have shown themselves to be as effective on various data sets. However, the clustering-based method have a number of problems. Firstly, they cannot be optimized to minimize diarization error entirely because the clustering procedure is a type of unsupervised learning method. And secondly, they have trouble handling speaker overlap since the clustering algorithm implicitly assumes 1 speaker per second. And then furthermore, they had trouble adapting their speaker embedding model to real audio recording with speaker overlaps because the speaker embedding model has to be optimized with single speaker non-overlapping segment. So this problem hinders the speaker diarization application from working on real audio recording that usually contain overlapping segments. To solve the problem, this research has proposed self-identity end-to-end diarization different from most of the other methods. The proposed method that does not rely on clustering, and instead, a self-attention-based network directly output the joint speech activity of a speaker for each time, given an input of a multi-speaker audio recording. This method can naturally handle speaker overlap during the training and inference time by exploring a multi-level classification framework. Now, turn to the next slide. I would like to talk about the impact of the proposed system. The proposed system can avoid greedy sequential clustering in case of extra-long sequence. A self-attention-based network directly output the joint speech activity of a speaker for each time frame, given an input of a multi-speaker audio recording. This system can provide minimal diarization error and achieve good speaker diarization performance for language conversation. And this can help extract important point or action item for Brunei conversation entirely who said that, and can identify how many speakers were on the audio. This system is able to supply any kinds of Myanmar language meeting with colleges. The speaker diarization will let an audio recording be turned into meaningful notes right after the meeting, and this can help automatic speech recognition performance in multi-speaker conversation scenario in meetings and home environment, and able to suppose that is an important process for a wide variety of Myanmar language applications, such as information retrieval from broadcast news, meetings and telephone conversation, speaker indexing and retrieval, etc. Now, turn to the next slide. I would like to talk about the outcome of the system. There are several benefits of making good speaker diarization systems, such as improving existing speech recognition system and making transcript more meaningful and searchable, and then assisting hearing impaired people with identifying different speakers on conference call, and speaker diarization has certain application in many important scenarios, such as understanding medical conversation, multimedia information retrieval, video captioning, speaker indexing and retrieval, speech recognition with speaker identification, and diarizing meetings and lecture. So this is about that many important areas of speaker diarization system. And then this results of data sets are real-time speech, such as interview, panel discussion, and talk show data to support existing speech recognition system, especially spontaneous speech recognition in low resources. The outputs of this system and technology to benefit for any language conversation and will collaborate with new partners and colleges. Now move on to the next slide. As a conclusion, speaker diarization is an advanced topic in speech processing. It's not the problem who spoke when or who spoke when. It is highly relevant with many other techniques, such as voice activity detection, speaker recognition, automatic speech recognition, speech separation, statistic, and deep learning. There are also challenges arising in the speaker diarization area, such as number of speakers, speech activity detection, and amount of overlap speech. So, end-to-end diarization is a neural network for speaker diarization, in which a neural network directly output speaker diarization result given a multi-speaker recording. The end-to-end methods can explicitly handle speaker overlap during trainings and inference times. It fits multi-speaker recording with corresponding speaker segment level. The model can be adapted to real conversation. So it could be believed that if the end-to-end method is used in this research, the experimental result will be good and can supply as a pre-processing step for various speech processing applications. Thank you for your attention.
Thank you for the presentation. This is the time for question and answer.
Thank you for your presentation. Very interesting work. I just want to confirm my understanding. So the input to this system will be waveform. Input to the system is the waveform. Wave.
That's
It the sound wave going in.
waveform,
Okay,
yes.
all right. Output will be label and word and speaker.
Speaker label,
Speaker
name,
label, but word no.
what, yes.
Word yes. Okay, so it like you solve the problem of who speak and when they speak, right?
Yes.
So the when part, how do you do a segment? The who part is coming from the label, right? But the when part, how do you segment that? Because segment now is based on the input.
Yes. The segmentation, there are two types of segmentation, pixel segmentation and non-pixel segmentation. Pixel segmentation will be difficult because in the segments for speaker, the input audio has many speakers. So pixel segmentation difficult for one speaker. So times maybe the force, maybe the by yourself. Yes. And then pixel segmentation will be used speaker change detection. Speaker change detection methods.
Okay.
This will be needs Bayesian hidden Markov model. Yes.
Right. But you use transformer, so the length sequence length is fixed.
Yes.
Yeah. And do you handle multi-speaker at the same time?
Yes.
You did.
Yes.
Thank you very much. Yeah, really nice work.
Any more questions?
Thank you very much for your questions. I have just one question.
Yes.
Have you considered the case when speakers are speaking in the situation where there is some background noise? For example, many people speak when we have music as a background, something like that.
Currently, we are use of less noise, real time conversation.
I see. So that means you consider the signal in the clean speed signal, right?
Yes.
Okay, thank you.
We have 2 minutes. If you have questions, please.
Yeah, thanks for the presentation. As you move from clustering, which doesn't require label, to self-attention, supervised learning, right? You would need some labels, right? In your case, do you know how many hours of recording do you need to make this work? Do you have the data or not? Yeah.
Sorry, one more time.
Oh, okay. So how many hours of recording labeled data do you think you need to make the system work? And whether you already have the data sets?
Currently, we are collecting data with our internship student. Yes. Then already already data set. Yes.
All right. How many hours?
Currently, we have 11 hours. Yes.
Okay. Thank you.
Yes. Any more questions? Yeah. Thank you for the presentation. Okay, let's move to the next presenter from Singapore and Indonesia. The title of the session is Building Natural Language Processing Resources for ASEAN Languages as a Region.
Hey, good afternoon, everyone. I'm Wei-Chi from AI Singapore, and I'll be presenting our project C-Core NLP, which is about building NLP resources for ASEAN languages together as a region. So without further ado, let me move into the background of the project. So as a national AI program, we work very closely with the industry to solve some of the problems with AI. And one of the signals that we get consistently from the industry is actually the fact that we need NLP capabilities for Southeast Asian languages. And for example, we see requests for things like Vietnamese chatbot or Indonesian information extraction. But when we try to solve these problems, we find that there's actually not a lot of openly available resources to solve these problems. And this is in stark contrast to high resource languages such as English. And here we can see that for the many tasks of NLP, for English, we have many data sets and multiple models trained on these data sets, and such that we are able to track the progress using a leaderboard. But this is not the case for Southeast Asian languages. So that got us thinking, could we perhaps do something for Southeast Asian languages to close this gap in the resources? So with that in mind, we have the following targets for our project. Firstly, to build open benchmark data sets for ASEAN languages for core NLP. So the idea of core NLP is actually something that we got from the Stanford Core NLP project, and it deals more with foundational tasks such as grammatical analysis and for major languages such as English and French. The reason why we are going with core NLP tasks is because these are generally tasks that are domain agnostic. And what we mean by that is actually that the grammar of a sentence, for example, does not change significantly across domains. So that means that we would be able to have a wider impact by allowing people to benefit from these data sets across multiple use cases. Now, having these data sets will allow us to train models, and we want to help the industry make use of these models more easily. So one thing that we thought of doing would be to showcase them on a demo website, and that will really showcase what's possible and in an easy to understand manner. And we want to have a Python package that provides a simple interface so that the industry can make use of this more easily. And lastly, and perhaps most crucially, we want to establish a regional coalition to promote knowledge and resource sharing, because ASEAN languages are relatively low resource languages, and we're going to need all the help that we can get. So moving on to the proposed solution, I would just like to deal a bit more in detail about each of those aims and what we have done so far. So just to define core NLP a little bit more, we get inspiration from the field of linguistics to look at language on multiple levels of analysis. So at the bottommost level, we are looking at morphological analysis, which is about analyzing language on the level of words. So here we have tasks such as tokenization and part of speech tagging. So from our survey, we find that these tasks are actually quite well taken care of, even if they are not the most accurate at the moment. There are resources out there. However, when we move up one level to syntactic analysis, which is looking at the structure of language, we find that resources are getting more and more scant. And moving up one level higher to semantic analysis, which is looking at the meaning of sentences, we find that there are virtually no resources available for things like co-reference resolution, as well as semantic role labeling. So for the purposes of our project, we define core NLP as all three levels, but we will be focusing on syntactic as well as semantic analysis because of the lack of resources in these areas. And previously, we talked about trying to create a Python package that is easy for use. We have actually produced a beta version of it, and you can download it using pip install. And from the bottom left-hand corner, you can see that it's quite a simple interface to use, and you can do training, evaluation, and inference just using a few lines of code. We also provide a documentation website that goes with this package, and it not only shows people how to use this package, but it also collates information, right? It serves as a sort of one-stop repository for information regarding Southeast Asian NLP. And moving on from here, since we will be publishing datasets for open use, we would also want to include the annotation guidelines for these datasets within this documentation website. And moving on to the regional NLP coalition that we were talking about, we have already established a preliminary network in the region, working with partners in Indonesia, Thailand, the Philippines, Vietnam, Sri Lanka, and India. And we work with them in order to create those data sets that we were talking about in the languages that are available in those countries. And you will realize that these are all universities that we are working with. This is important because we need the right manpower in order to do these projects. So previously I mentioned that we are looking at doing semantic and syntactic analysis for language, right? And this is going to require quite a high level of linguistic knowledge in terms of creating such data. So we find that working with graduates and undergraduates in linguistics is quite good for doing such tasks. And we also work with professors doing research in NLP and linguistics, so that when we adapt existing guidelines to the languages that we are doing, we know that the decisions that we are making are based on sound research as well as linguistically motivated. Moving on to the impact of our data sets. We have benchmark data sets that will help us to evaluate our models more meaningfully. And this will also allow us to have leaderboard competitions, which will help us to catalyze research and development of new language models, as well as novel NLP solutions. And at the same time, having such rich linguistic annotations will help us to promote linguistic research and allow us to probe language models, allowing us to see on what kinds of linguistic phenomena our language models are not performing as well, and then we can further improve on them in that way. And in so doing, we improve the interpretability of such models. At the same time, there's also the impact of the models that we train on such data sets. So we can look at it from a direct usage as well as an indirect usage point of view. One example of a direct usage of these models would be for information extraction. So here we have an example of a news article, and we apply some of these methods to get information out of them. So for example, we can use NER to extract entities from the data set. And we can also use semantic role labeling to find out who did what to whom. So that gives us an idea of the actors that are involved and what kinds of events and actions are happening within the text. And we can go one step further to use co-reference resolution to find out which entities within the text refer to the same real-world entity that will help us to better cluster the information within the text. But we can also use the output from such models in an indirect manner, which is to use them as features for downstream tasks. And this would then allow us to really apply the output across a lot of different use cases. So one of the good examples for this would be machine translation. And a lot of research has shown how we can make use of such semantic and syntactic features to boost the performance of machine translation models downstream. Moving on to the outcomes. We are happy to say that for the data sets that we wanted to create, right now we have already created 3 Indonesian data sets, and they are actually right now the biggest or largest data sets available for each of their respective tasks at the moment. We have also written some research papers regarding these papers, and they are currently under review. So we aim to do the same for other languages, and right now we have datasets for Thai and Tamil undergoing annotation and quality control, and we will be very happy to open them up once we are done with them. And throughout this process of linguistic annotation, we have really found that working together as a region really speeds things up, because despite the fact that all these languages are from diverse language families, research has shown that there are a lot of typological similarities across them. And when we find challenges in one language dealing with a particular linguistic feature, we can learn from that and transfer that to the other languages that we are dealing with. And that allows us to make better decisions and create better quality data sets as we move along. And last of all, we have that image over there, which is the demo that we have already created. It is of course not complete as of yet, but we already support all the tasks that we have mentioned. And we support mainly Indonesian, Thai, and Vietnamese, with certain tasks covering languages like Burmese, Khmer, and Lao as well. So in conclusion, we want to build high-quality benchmark data sets for Southeast Asian languages. We want the industry to be able to use them easily, and we also want to get the region to work together towards this goal. Right, so for future works, we want to scale up our operations to include more languages and tasks, as well as larger data volumes. And we also want to grow the regional network to more countries and organizations. So if anyone here is interested to explore some collaboration opportunities with us, we would definitely be more than happy to have a chat with you as well. So this is the end of my presentation. I just want to give a quick shout out to some of the partners that we work with. We are supposed to have Dr. Ayu with us today, but due to some other commitments, she cannot make it today. Yeah, and we also want to acknowledge Datasoft, who has provided us with the annotation platform for our projects. That's all from me. Thank you very much, and we'll take any questions from now.
Thank you for the interesting presentation. Now, this is the time for question and answer. So please. Yes, I have one question. In doing the benchmark data set, I like to know that do you use the Asian language tree bank in your benchmark data set?
Yeah, so right now we are actually creating new data sets, but of course the Asian language tree bank is actually a source of inspiration for us as well. So actually some of the models that we put onto the demo website as well, they were trained on the Asian language tree bank. So we do have a Burmese constituency parser on our website, for example.
Yeah.
Yeah.
Thank you.
Thank you.
Any more questions?
There was some project before of IVO on natural language processing. Do you have any document or search on the documentation of the projects before?
So
IVO project?
You mean similar projects done on such language annotation projects?
Yeah. Because of some they had some result before.
Right.
Yeah.
Yes. So we took whatever we could from what is out there right now. So we consolidated all the resources out there and whatever projects have been done before onto that documentation website that we talked about. So they're all available there. But we are building on top of whatever is already out there. So we try not to overlap with what is already done. There was one, I think U-Star, but that one was a bit more towards speech data. And it kind of ended, I think quite a few years back. So yeah, we try not to do any overlaps with currently available data sets.
Thank you. And any more questions? Okay, now it's time to conclude our session. Thank you for the presentations. Thank you all.
With the conclusion of this session, we will now be moving to a 10-minute break. So anybody who would like to go and get more coffee or other refreshments can leave the room now. Excuse me, just a moment. Connection loss.
Connection loss. What to do the Well, assuming it's
So here.
we'll make the sorry. Oh, yeah. Okay.
So anyway, so 15 minutes, I press this.
Okay.
And then your speaker speaks.
Speak, yeah, and then until 12 minutes, then 3 minutes for discussion. Yeah, 11 minutes, 1 bell, 12 minutes, 2 bells, 15 minutes, 3 bells. Yeah, it has been like that since many years ago, since Phnom Penh. Let me say, we will start. Can we invite? Because our plan is to finish it to start at 4:05. Session 7. Oh yeah.
So, and everybody was being late.
Yeah, everything was late, including my lunch.
Oh, really?
Yeah, our lunch is late. So
Oh, no.
this time we only have lunch for 20 minutes.
That's true. With the IT people. Because if they don't have connection, you don't have the program.
Okay. For the presentation. And it is difficult for them to talk with her.
And the, I'm sorry? Oh, you can start. Okay. You can start.
Okay. Ladies and gentlemen, let's start with the final session. This is session 7, ICT related technologies and applications. My name is Aswin Sasongko from Indonesia, and I will chair this session 7. We have 3 speakers. One is Mr. Hana Arisesa. Second is Mr. Hana Arisesa from Brunei, Indonesia. And then we have Mr. Buncai Ngamwongwatana from Thailand. And the third one is Mr. Hamam Risa from Horika, Indonesia. Can we start with the first session? And for the speaker, we will have 12 minutes for presentations, then 3 minutes of question and answers. After 11 minutes, there will be 1 bell ring, and then 12 minutes, there will be 2 bells, and 15 minutes, there will be 3 bells. Okay, Mr. Hana, please start the presentation.
Okay, thank you. Good afternoon, everybody. It is an honor for me to be here. Thank you for the committee who invite us for one of the speakers today. On the behalf of Dr. Yusuf Nur Wijayanto, he is our principal investigation in this research, but unfortunately he is on the duty, so I will replace him in these sessions. I am Hana Arisesa from Research Center for Telecommunications, National Research and Innovation Agency, Brunei, Indonesia. Today, I would like to talk about the investigation wireless microwave propagation characteristic 5G and beyond in the ASEAN region. So, this is our background. Today, there is a gap between developed and developing countries, especially to build innovation and research capabilities. But there is chance to change that. Every nations should be increasing their capability in research and technology, especially for reaching their Sustainable Development Goals (SDG). According to UN, that SDG 10 and 11, such as to reduce the inequality among the countries, between developed and developing countries, and to make cities and human settlement inclusive, safe in the future, better and better. One of the possible good technology in the future is wireless telecommunications. So today, wireless telecommunications technology is still growing very fast, approaching a new technique and new technology. 5G and beyond, more higher and higher frequency. There is more complicated and there is more different aspect. So in the ASEAN regions, what is the ASEAN region will take part in this new technology? So I want to emphasize for the uniqueness of ASEAN environment as challenge for future wireless technology system. As you know that ASEAN's maybe have it has maybe 600 million inhabitants, various land topography, different topography, different propagations, and has many extreme temperature, rain intensity, durations, tropical forests, and many natural disasters. So this is our capability to show the uniqueness of ASEAN's conditions. What about the current technology in wireless technology in ASEAN? Maybe in case of Indonesia, we're currently discussing about a 5G technology using open runs is already running in Indonesia, but we are still discuss the regulation and recommendation, so on and so forth. So the uniqueness of ASEAN environments to be explored for the sake of future wireless implementation in ASEAN's in general and the world in general is very important. So this is based on our objective, this is our target. First of all, to provide propagation loss data in various environmental conditions in ASEAN for the establishment of the future wireless generation in ASEAN. Maybe focus on a millimeter wave band and maybe in a sub-terahertz and maybe a more and more higher frequency. And the second is to exchange, to share the ability of propagation research among the ASEAN countries and in Japan with mutual cooperations, and to provide useful research data for better decision-making process for triple helix stakeholders. I mean, for the government, for the business side, and for the academics community. And the last is to increase engagement of triple helix stakeholders for establishing research on wireless technology at local and regional systems. This is our proposed methods. The uniqueness of environmental aspect in ASEAN regions has many parameters, such as land and topography, and how we can do the scenario to deal with the measurement of these propagation data, line offset, non-love offset, MIMO, outdoor and indoor scenario we can apply to measurement this data, and what are the phenomena should we address the effect to the wireless communication system. Of course, existing available data in the some part of world, Europe, US, and other parts is already published in several communities, and also international body standard like ITUI, FCC also have their recommendation and standard itself. But we can do more measurements about our conditions, uniqueness condition in ASEAN regions. So we can do also simulation to verify this data and this model. So we can plan our measurement, our simulation, existing data in this, and already published standard and recommendations. We can more get understanding about our uniqueness data, our uniqueness conditions data, especially in propagation data for the wireless telecommunication technology in the future. What is the uniqueness of environmental aspect in ASEAN regions? Of course, there are many uniqueness in our countries, in ASEAN countries, such as maybe every year several countries occur wildfire, and in Indonesia and some other parts, and the topography itself, we have a value, we have valley, we have mountain, we have marine, we have peninsula, and so on and so forth. And so river city, marine city needs to be addressed. What's the effect from the wireless communication systems, especially for 5G and beyond? The world is getting hot and hotter today. Extreme torrential rains occur in the tropical countries. Maybe it has effects to the performance of wireless communication system. So this is our proposed method. We can do a measurement and simulations, both simulation and measurement and simulation as well. This channel sounding is a famous method to do propagation measurements data, but lately UAV like drone and something like that is getting more high attentions to be involved in the wireless communication system. We can mimic many drones for transceiver and receiver itself. So in other part, we can do a simulations using license or maybe open source software. We can make more parameter like using many methods, ray tracing, foliage effect, terrain, and so on and so forth. We can verify with measurement and the simulation itself. This is one of already existing experiment for myself, existing experiment in the wireless propagation data, mimicking precipitation in various intensity at 300 gigahertz frequency. So what is the impact in this proposed research? First of all, the scientific and technology impact. So we expect the participation of in academic forum, local and regional and international conference, as well as publication in reputable journal for each participating countries. And we try to provide open the data sets about our uniqueness condition in ASEAN region for the sake of triple helix stakeholder, from the agency, from the policy, from the business, and from the academic institutions, and promoting ASEAN IVO in an academic engagement in research and wireless technology research. So we need more collaboration and new and maybe more and more collaboration in this topic research, because we need more participation for researchers in ASEAN countries, achieving transfer knowledge, visiting researcher, and sharing the data, sharing the analysis to get more and more understanding our uniqueness ASEAN conditions for the future wireless communications. So we can also contributing to improving research and innovation potential at a local and regional level, creating and maintaining a regional research group, especially in the propagation data research. And the last is very important is the policy. A study and recommendation for authority in each our country or maybe in regional countries for the future implementation of wireless technology through a better science-based policy. And then what is the next, our output and outcome. There are three impacts in the output and outcome. First of all, the scientific, and the second is societal, and the last is collaborative. For scientific, we need more and more increasing expert on the wireless propagation research among ASEAN researchers, which is maybe in my view is still not very much. and accessing the propagation characteristic data for unique environmental condition in ASEAN regions. And maybe we can develop a new propagation statistics method for challenging environmental condition according to ASEAN situations, such as using UAV drone for the certain and critical conditions, such as disaster, natural disaster, earthquake, and ruined building, and so on and so forth. And about the societal output and outcome, the data set of propagation characteristic of the target environment in ASEAN can be provided in this research. And research study report of the propagation data for authorities. And for the last is a collaborative. We need to increasing participation ASEAN researchers in international, regional, and local scientific events, such as conference and journal at the wireless technology research for each participating countries. So this is the conclusions. What is our target? Our target is to research, to investigate, and to investigate the propagation characteristics data based on the uniqueness of environment aspect in ASEAN regions for the implementation future wireless technology system. What is our methods? Our method is combining both a simulations design and experimental approach, and verifying with existing data and published standardization and recommendations on various aspects of target environmental system to develop open data set of the propagation characteristic for future wireless system. And the last is scientific and societal impact is to contribute the important data sets in various unique environment of ASEAN regions, and participating scientific wireless community, and supporting is very important, is supporting national strategic mission and policy on the implementation of future wireless technology in ASEAN, and engaging local and regional triple health stakeholder to increase technology sharing knowledge for better human development capacity in ASEAN. This is last call join for collaborations. The candidate collaboration is Dr. Yusuf Norwijayanto. You can contact him, and we can contact me as well. We can discuss after this or later on. And Prof. Sevia Idrus from UTM Malaysia, and Prof. Atsushi Kano for Nagoya DBT Japan. Thank you very much. Thank you very much.
Thank you. Thank you, Ms. Rana. Any question from the floor, please?
Yes, please.
Yes, please.
Okay, so thank you very much, Mr. Hana, for a nice idea and also some purpose. Actually, I did this research in 2019 and made publication in IEEE, and we call 5G Indonesia channel model, and we made experiment for Java Island, and then this year we are making for Sumatra Island. So your proposal here is to extend for the ASEAN, and then maybe this is also a good idea. We can have ASEAN 5G ASEAN channel model maybe by doing this. But from the scientific view, this is very good. But I think we need more than that. We need more than just 5G ASEAN channel model. But we need what is the impact of knowing the ASEAN channel model to the economy, for example. For example, this is very interesting if you can make connection between what is the best bandwidth used by each ASEAN country such that it increase the economic level for the countries. So would you please give the comment for that purpose? Thank you very much.
Thank you very much for the questions. My response is research on the wireless propagation data is not a simple research. I think we need more and more collaborations, especially for the scope of ASEAN. So why we are right now here, we try to join for all the participants to build our idea and joining for the next level of propagation data. So there are many constraints in propagation wireless communication system research that maybe we can discuss more later on, because I think it's not trivial research, but we need to support for other ASEAN country. We need more discussions about this. So this collaboration, big collaboration for sake for the future ASEAN system and conditions. Thank you very much.
Thank you, Mr. Hana. Because already time finished, and yeah, I think we can discuss it outside, Mr. Abu. Next speaker will be Mr. Bunchai Ngamwongwatana from NECTEC.
Hello, everyone. My name is Bunchai Ngamwongwatana. I'm working at National Electronics and Computer Technology Center, or NICTEC, in Thailand. My work, the title of my work is Automatic Service Recording System using Network-Based Monitoring Approach. Okay, some background about the work. This work is a collaboration between NECTEC and Thai Telecommunications Relay Service, or TTRS. TTRS is a public organization offering video relay service, usually called a VRS. It's a service to persons who are deaf, hard of hearing, or having speech difficulties. The organization was founded under the USO, or Universal Service Obligation, which is the fundamental consumer protection policy in most countries, to ensure that everyone has access to telecommunication services. With 4G and 5G communication, VRS users can make a video call to the center, and the agent, who is a sign language interpreter, will help to place a call and relay the conversation to any person. The VRS service is very efficient and most preferred by the deaf community because the flow of conversation is much more quickly than the text-based relay option. The goal of this project is to record and archive video relay services at TTRS. There is needs for this, for example, for service evaluation, verification, improvement, interpreter training, and examination in case of appeal. The existing workflow is not very efficient because the agent has to involve in the process manually, which has an impact on the workload and efficiency. The target of this project is to make the whole process fully automated, so the agent can focus on providing the VRS services. The process might also be intelligent to be able to identify the caller, type of services, and collect and save the detail of the corresponding services. In our proposed method, we propose to use the network-based monitoring approach to capture network traffic. The system will analyze network packets, call signaling, and related protocols. Call signaling is based on SIP and SDP protocols that normally used in voice over IP. We can detect call activities, collect call information and details. The audio stream and video streams are based on G711 and H264. There are a lot of details on how to handle these title payloads. And I put the references here. The RFC 7655 for the audio and RFC 6184 for H.264 encoding. Then the system will reassemble relevant media streams and create raw audio and video files. These files are then edited and recomposed to create the final video file that capture the whole VRS conversation. The video files and call details are automatically uploaded to the cloud storage. This is an example that the system can analyze and visualize the call signaling and media streams with details. On the left, you can see the caller who make a video call. You can see the signaling media streams. There are two for the audio, go forward and backward, and two for the video, go forward and backward. And on the other side, on the right, the agent helps to make a cell phone call to a phone number. And there are two audio streams on the right side. And the implementation of this work is based on Java. We use PCAP, the very popular library, the PCAP, packet capture and FFmpeg library. The challenge is how to process many real-time interactive multiflows of media streams. The optimization is vital. The processing must be swift in time without causing the buffer overflow. We propose a new methodology called multiple buckets, as opposed to traditional single bucket. On the image on the left is a traditional single implementation of PCAP. On the right is the multiple bucket PCAP architecture. On the left, usually we have only one instance of PCAP. On the right, we try to create necessary PCAP instances dynamically to be able to handle a lot of traffic faster. In our experiment, we monitored the input, the output rates, and utilization of PCAP buffers. Output, see from the table, output rates are slower because time spent in the processing, and also that also causing the buffers to build up. Going down, you see call duration, as longer call durations need more buffer. However, normally PCAP buffer is limited. We assume that we don't want to change or modify any PCAP library. We use any PCAP that you can find in the open source. The experiments showed that multiple buckets can reduce buffer utilization around 65%. Look at the column for the buffer utilization on the green compared to utilization on the blue column. It's lower. This is the output. Image on the left is the agent who provides VRS services via cell phone-based application. The caller, in this case, is a Grab rider. He needs help to contact a person to deliver food. The caller makes a video call in. On the right side is the application that we developed. The recorder detects a signal, the call coming in, and it starts recording automatically. The recorder continues to record while the agent makes an outgoing call to a third party. And this is a recorder portal. It's a web-based that gather all the details, information, allow the admins to easily monitor the VRS services. You can see there's a column for date and time, the caller, the agent, and the service in this case, it's VRS that make a call to other phone number, and the admin can click on the to play video, can search and play video in sharp and native resolution. In compared to normally when we use the cell phone. Can I go back? Oh, usually when we do a cell phone, we can see that we have a smaller video for ourselves, but it's very hard to see the sign language. When we do record using network-based, we can gather the video in sharp and native resolution. And in conclusion, in this work, we presented our R&D project under cooperation of NECTEC and TTRS. TTRS provides video relay service to persons who are deaf or have speech disabilities. The project goal is to record and archive VRS services for evaluation, improvement, etc. The important thing is the whole process must be fully automated and intelligent to be able to record and the relevant video and phone calls among the parties. We propose the network-based monitoring approach, which can automatically detect the calls, analyze video and audio streams, create video files of the VRS services. The project helps to reduce the agent workload. The agent can focus on the VRS services to the callers, and the overall efficiency and utilization at the TTRS are improved significantly. And finally, this work can be connected or extended in other projects as well that involves network traffic capture for analytical processes. And that's the end of my presentation. Thank you for your attention. Any?
Thank you for giving more time for questions.
Okay, any questions?
So we have a lot of time of questions, so please, the floor can give the questions. Anybody would rise? Okay. Meanwhile, can I ask short question? Is your system for the automated system also include for the TTRS or VRS to have an option? Okay, I do not want to record this one because it is what call it secret or whatever it is. You do not want to record. It is not. It is automated, but I can choose not to record the discussion.
We used to have that option, but it depends on the center. Currently, they want to automate everything, so the agent can focus on the job. But later on, they can choose then this call they don't want to. That there is no need to record. They can delete it later.
Oh, I see. They can delete it later. Okay, thank you. Anybody else? Anybody from the floor? Okay. So if not, then thank you for the great presentation.
Thank you very much.
Yep. Ladies and gentlemen, now we have the final presentation from Dr. Hamam Riza and about the AI and IoT predictive maintenance smart monitoring system. That is about artificial intelligence. Please, Pak Hamam.
Okay, very good afternoon. Greetings to everyone. Last but not least, my presentations finally. I'm quite happy coming back to the ASEAN IVO Forum 2022. After last year, we have it in Telkom University in Bandung. So let me present some of the work that have been done by our colleagues. Myself, Rahmat Darmawan, Noval Indiatmoko, Sony Alfatani, and Christian Kurniawan. All of us are from the Collaborative Research and Industrial Innovations in Artificial Intelligence. This is an association that was formed after the launch of our national AI strategy back in 2020. So I want to share with you a predictive maintenance that takes data from multiple and various sources. This is something that combines information technology in general, IT operations, and use machine learning techniques to anticipate equipment failure before it happens. So smart monitoring system is a term that we coin that to comprise the overall operation of an IT system. So organizations are facing increasing pressures from growing IT complexity, customer demands, ongoing security vulnerabilities. And in response, we are embracing new strategies that leverage artificial intelligence for IT operations. Thus, we found that the okay, no problem. Yes. Maybe the connection. Oh, okay. Huh? No, no connection. So even the Zoom ID is also Zoom meeting is also very tired because it's very quite late. So okay, thank you so much, Somi-san. So let me continue. So we need to have a new strategies that leverage artificial intelligence for IT operations. And this is where AI operations comes in. This is to automate and improve how we develop and run the IT operations. AI operation is AI and IoT can provide high-level overview of the process, especially in the IT operation, and involved in setting up a predictive maintenance program for any type of high capital asset, whether it is a heavy machinery, fleets of any kind, manufacturing equipment, and especially on ICT infrastructures, data centers, network operations, security operation centers, etc. The smart monitoring system that I coined in to comprise the IT operation is a solution to provide the real-time status reading and a predictive indicator of an infrastructures. The key lies in not just simply monitoring the various time series, as you can see in the visualization of this map, we have so many command centers and data centers around Indonesia as part of the IT operations of many institutions, not limited to the government. And coming from this time series data, actually, we can employ machine learning algorithms to take actions for real-time insights. A classification model is developed to predict the state of the monitoring target, whether it is still working or is it in failure status. And the sensor readings are fed into the classification model to predict whether or not the monitoring target will be in failure state in the near future. Using this time series data, it is possible to predict sensors reading using supervised learning method, such as long LSTM and GRU. We have run the simple experiments using this architecture coming from input of IoT sensors reading time series data and historical operations, and coming into the algorithmic machine learning process where we do the feature extractions and deep learning and output the time series forecasting and classifications. Sorry. Okay. And coming from that, we have and from this output, we have the outcome, whether it is descriptive artificial intelligence and predictive AI. We did a mini experiment, I will say, with several IoT sensor readings. The color indicator or threshold can be attributed to each sensor. As you can see in this slide, there is a temperature IoT sensor, acoustic, noise IoT sensors, light sensors, moisture, water level, presence and proximity sensors, as well as chemical IoT sensors. And we run this experiment with limited features here, such as temperature, humidity, voltage, and memory indicator. And coming from this data source, we were able to do the data analytics on this particular patterns, and then created the hypothesis validations to have the data-driven decisions, where we set up the initial threshold value for each sensors and come up with the final model which can predict the sensor readings in the futures. The predictive maintenance scheme can be seen in this slide through two kind of tasks, which is first the regression task, and the second one is the classification task. In the regression task, we did pre-processing, time series forecasting, and a regression model, as well as the similar scheme that we use for the classification, building up the classification model, where then it was integrated into a prediction and decision support. Some example on this particular experiment for predictive maintenance is showing some of the monitoring of several assets here, such as like 46 data centers and 16 radio stations and other security operation center. And the indicator, the blue indicator, shows up the current status and the forecast. Yeah. So this means that the AI operations, which is the umbrella term for the use of this big data analytics and machine learning and other AI technology, is particularly interesting to automate the identifications and the resolutions of the common IT issues. Outcome of this work is ICT system with intelligent predictive maintenance capabilities will be the mainstream in the future operation of various infrastructures, especially on ICT. And combine, we say this as a ABCD plus X technologies, AI, blockchain, cloud, big data, with X such as Web3, communication protocol, sensors, and embedded system, and especially probably forthcoming 5G technology or even 6G, like we are discussing today. Then AI and IoT can accelerate innovation in the development of continuous ICT operations. In conclusion, given the resource spent on maintenance across industry today, predictive maintenance is a critical step in reducing costs, increasing productivity, and ultimately staying relevant in an era where cutting-edge data-driven businesses are gaining market shares. Through the initial cost of implementing a predictive maintenance strategy, which may be steep, companies today are already proving that the returns in increased productivity plus the reduced costs are available returns. AI, IoT smart monitoring system is just a preliminary use cases for ICT operation, and we believe if we move into the smart cities area, smart mobility, and many other use cases where we need to run the operation smoothly, then this kind of solutions can be developed. And to further these collaborations, we need all of you from the ASEAN partners to join hands for the better future. Thank you so much for your attention.
Thank you for the interesting presentation, Pak Hamam. And ladies and gentlemen, if you have any questions from the floor, any questions from the floor? Since AI is the future, yes.
Okay, I think for predictive maintenance or predictive system, normally we use like historical data to classify or to identify existing failures. What do you think how such system can like predict failures that we don't know yet? Because it does happen in real engineering implementation as well. Thank you.
Yeah, good questions. Can I go straight ahead?
Yes,
well, you're basically right. Historical data is something that we try to collect from a time series data coming out of this sensor. So we built this system of sensors using wireless network, okay, mesh network, and we collect data to actually look at some of the routine process. Routine practice, which include sometimes a user request for such a non-critical IT system. And for example, AI, we can also enable a help desk system to collect this data, because the user probably will sound the alarm for this kind of incident. So in order for us to process and fulfill user request data, this data can also be used as historical data. And then certainly we need data to recognize some of the serious issues of running the IT operation. And usually IT professional might address a known malware event, for example, on a non-critical system. So this kind of insight and data is also used to do some of the predictive maintenance, to formulate the predictive model, using the machine learning and probably deep learning. So we just use two kind of supervised model at this time, but I believe that many other models, including some of the latest pre-trained model for AI operation can be also used. Yeah.
Thanks, Phon-Am. And there's another 2 questions, please.
Yeah.
Thank you for the interesting sharing, Phon-Am. You've been talking about this predictive maintenance on a more hard aspect of it, but there is definitely a soft aspect of it to, action on it, risk management of, when the model is failing. Perhaps you can comment a little bit on that.
Yes, you're true. So running the predictive maintenance is something that we want to have as part of the IT service management, ITSM. So if we look on this particular issues, then the IT service management will be improved by having automated service maintenance, automated or schedule maintenance, and it will lower the unscheduled maintenance that happens. We want to be able to mitigate the risk of unscheduled maintenance, and in this case, the IT governance will come in, into this.
Thank you.
Thank you.
Thank you. We have one last question. Last presentation, last question.
And from my friend.
Yes. Okay. Thank you very much, Dr. Aswin and also Dr. Hamam. Very short because already bell 3 times. Okay. So speaking about the predictive maintenance and also the explosion of the data, and also when we make connection with this morning keynote about the cloud and also the digital economy, which is also extending into the digital first economy. So some countries are predicting that for the cloud computing, they are trying also to use the quantum computer for the high speed of computation and also the security because of no cloning theorem. So do you think that for this predictive maintenance and also smart monitoring in the future, and also for the ASEAN, we need such kind of very high end future computation? Thank you very much.
Thank you. Exactly. So I support your actually comment actually in this, that we will certainly need more computing power. We need to have more data set in order for us to explore a bigger data set. That's why big data analytics and AI, as I mentioned earlier, the technology, blockchain, including all the communications protocol, whether it is mesh sensor network or something like that, will be a significant progress in order for us to combine all this for the operations of many automated systems. So it's I think I reckon digital transformation is going very well across the ASEAN regions, and all of us are we are not just a follower of digital transformation. I see many ideas have come up during this day for today with really bright futures for all the research and implementations and innovations in ASEAN. Thank you.
Thank you, Pak Hamam, and we give appreciation for the last presentation on AI.
Thank you.
There's a lot of question and answer, and hopefully at the next ASEAN IVO meeting, there will be no moderator, no timekeeping, because that will be replaced by AI too. Thank you.
Okay, so next on our agenda today, I would like to invite Dr. Yano Hiroyuki, Chair of ASEAN IVO Steering Committee, to please give your closing address.
Thank you, Dr. Arisan. And it's time to closing today's forum, everyone. So I'd like to thank you for all participation, the presentation, the chairpersons, and your stewardship and arrangement at each locations for long hours. It's from the morning, we have the 9:30 to through the almost 5:30 p.m. It's a long hours. We had long hours. And I heard we have almost 140 attendees on maybe in here now it's almost 70 in this hall, but the online is the Zoom and the YouTube and almost 70. So it's almost some summation of the 140 attendees we have. So today we have two keynote speeches, impressive keynote speeches, and 20 interesting and impressive presentations. Thank you very much. And fruitful discussions. And we learned several social problems and learned several technologies to solve those problems. I think it is not the age when important research issues can solve the efforts of the just one individual and one institute or one country. So combination or joint workshop, joint program, joint works is important, I believe. So I hope that today's presentation and the discussions will be the inspiration for future joint projects in Asian countries. Thank you for participating in this hall and online today, everybody. So hopefully next time also we will be able to gather under the same roof. So I wish keep your good health. Thank you very much.
Okay, so before we conclude the forum today, I do have a few announcements. So the first announcement is the call for proposal is now open. You can visit this website and please submit your proposal. Okay, so on this website, now the call for proposal of 2023 is now open, so please do join by submitting the proposal. And also, the last announcement is for dinner tonight. The dinner reception is going to be held at room Mandarin C, CCAT, like Mandarin C. It's located on the first floor of the Mandarin Hotel. The dinner will start at 6 p.m. For those who stay, for the steering committee, project leaders, speakers who stay at the Mandarin Hotel, the van will be waiting to pick you up and take you back to the hotel. So for other local participants, please arrange your own transportation, and we do hope to see you at the Mandarin Hotel. So dinner will be at 6 p.m. at Mandarin Hotel. Thank you very much and have a great day, and hope to see you all for dinner tonight. Thank you. And just one last announcement, sorry. For the steering committee, for the project progress for tomorrow's meeting, the meeting will be on the building number 3.